Hello, everyone. Hopefully you guys can hear me, those of you that dialed in as members of the public. This is Julie LaRock. We are waiting to start the Technical Oversight Committee meeting. We're missing a couple of panelists and Mr. Barquette right now, so please be patient with us for a few minutes until we get everybody on the meeting. Thank you.
Good morning, this is Dan Crawford joining.
Hi, Dan, thank you. I was just going to check. So we're looking for Mr. Barquette, and then we can get started. Thank you. For those of you that are attending as members of the public, please be patient with us for just a moment or two. We're waiting for one more individual to start the meeting. And I see you guys are all logging in. That's great. If you have any issues, please try using the chat window, and Lisette DeCastro will help you. You should see some information on your screen related to muting and unmuting yourself. So we'll go through all that in a minute once we get started.
Hi, sound check. This is Lori.
Hey, Lori, I can hear you now.
Yeah, thank you.
Okay, great. So sorry. My computer just decided to blow up starting at 7 o'clock this morning. So my apologies. I am here.
Okay, and I just sent a note to Mr. Barquette. If we don't hear back from him, we may need to go ahead and start without him, but I prefer to have him on the line. So give us just a second. Darren Aquino, you've got your hand raised. I sent you a chat message. Is there something you need before we get the meeting started? And for the other TOC reps, if Mr. Barquette's not on the line, are you guys okay with starting the meeting?
Do we have any precedence for having a meeting without him?
Well, there have been a couple of meetings that Mr. Barquette had someone else on the line on his behalf, and I gotta tell you, I just can't remember. Maybe Darren is that person, but I don't have a response from him right now. I'm not aware of any actual requirement to have Mr. Barquette here. I don't know if any of the attorneys who are listening in have an opinion, but feel free to email us and let us know if you think we need to continue waiting. Otherwise, we've got a lot of folks on the phone.
Hey, Julie, this is Dan. From the Corps' perspective, we're ready to proceed.
Thank you.
This is denied. I would like to give them a moment, the lawyers, to respond. If they don't, then let's go forward. It's all documented and being recorded, so it just doesn't give him a chance to give input, which is my concern.
Henry or Devon, could you please open Judith Coleman so she could speak? She's an attendee. She has her hands raised, and she could probably advise us on the Mr. Barquette question. Okay, Judith, you should be able to speak up now. Except I can't hear you.
But she has to unmute her phone.
All right, Judith, you've been unmuted on our end. If you could unmute on your end, then I think we could hear you. Or maybe not. Okay.
That's *6 if you're attempting that on your phone. *6.
Julie, this is Stuart Van Horn.
Yep.
If there's a way, maybe if Judith is not able to, or we can't hear her, maybe she is able to chat. I'm not sure if that function is available for her to be able to.
It is available. Judith, you could certainly send a message using chat. So hover down at the bottom of your screen and you could type in a chat message if that would help. I don't really want to hold everybody up here. It's one of those wonderful odd situations that we have at the moment.
Judith, I don't know if you can see the chat box, but people are chatting to you. If you could respond to the chats, that might help us through this process. Okay, it looks like IT is having to unblock her. There was some kind of default block put, so we're having to wait on that.
Thank you.
She says it's working now. Does that mean you can talk or just text? The mic is not picking her up. Can you text us if we can go forward with this, or do we need to have Barquette? She says she does not believe there is a requirement for the special master to be on. Let's go.
All right, great. So everybody,
Thank you,
start. Let's go ahead and do that so that we can keep all our fan club here from hanging on the phone. Thank you, Judith. I appreciate the feedback. All right, everybody.
Julie, this is Frank, and I confirm the same thing with my general counsel also regarding, the special master is not legally bound to be at these meetings, but it's as we get towards the voting, if we have a voting scenario today, we may want to hold those off until he's available. Just a thought.
Okay. All right. Thank you. And I really wasn't sure if the other person trying to speak, who also just disappeared, if he might have been representing Mr. Barquette. So, all right, everyone. Well, let's go ahead and get started. This is Julie LaRock. This is the Technical Oversight Committee May meeting, which is a quarterly or annual meeting, depending on your perspective. We are using Zoom media technology so that everyone can participate as best as possible, but without coming into close contact with one another in case we're sick. So if I could have the reps introduce themselves so that the participants are somewhat knowledgeable of your voice. I'm going to go through some other hints and instructions after that. So this is Julie LaRock representing the district.
Donato Surratt, Everglades National Park.
Lori Miller, Loxahatchee Refuge with the U.S. Fish and Wildlife Service.
This is Frank Powell, Florida Department of Environmental Protection.
And this is Dan Crawford with the Corps of Engineers.
Okay. Thank you, everybody. Susan is on the line. She is our court reporter who is normally sitting next to me in the auditorium. So she's virtually sitting next to me right now and recording on her little stenography stuff what we're doing. If you are on the phone, please mute when you're not speaking. There are two ways you can mute and unmute yourself. One might be with your actual telephone if you're using it, and then there's a way to do that through the Zoom software. So just remember, you only want to be on audio in one place. So you can raise your hand by pressing *9 on your phone, I guess, and you could probably use a mouse or something to raise your hand. When you're called on, you'll want to unmute your mic and or your telephone, and please, before you speak, state your name. So we just introduced the voices of the representatives, but each of us ought to try to remember to state our name before we speak. And based on some prior experience, when you are unmuted, give it a couple of seconds before you start speaking so that the computers and all the electrons in the sky can catch up with us. We will take public comment from those of you who are shown as attendees either before we vote on something or at the end of the meeting. Any other type of general comments we'll also take during the public comment period at the end of the meeting. So hopefully this will work out for everyone. We are not taking written public comment. Of course, you guys, anyone here is always welcome to send an email at some point so that we could address it. If you are an attendee or a member of the public that is called in, our IT folks who normally are in the back room of the auditorium helping us, I will call your name and they will unmute you from their side of things. So please kind of bear with us as we work through this. If you have technical difficulties and you're actually on the Zoom meeting, you could use the chat box, which I assume is the same for everyone. You kind of hover at the bottom of the screen and you see a chat window. And I see that Darren Aquino actually did try to talk, but I don't know what happened with Darren, so I want to mention that. Let's see, use only chat. Okay, we're not gonna, as normal, we try not to engage or respond in a big conversation with the public comments, but we will make sure we get your comment or question and get back to you. We'll take action items and so forth at the end of the meeting, as we usually do. So that's kind of a little synopsis of doing a meeting by Zoom. For those of you who have used Zoom elsewhere in other forums, we're using the webinar format, which means no video. That's why we have to speak our names. And part of the reason for this is because we're trying to avoid hackers barging in on our meetings. You may have seen some interesting news stories on that subject, but we're working hard to keep that from being an issue for our public meetings at the district. Any questions yet from any of those of you who are speaking? Okay. All right, so let's see. We did welcome, we did announcements, we identified people who are on the phone for the most part. Those of you that are public participants, you know, we usually offer you an opportunity to introduce yourselves at the beginning of the meeting. We're not going to be able to do that. If you registered with your name, we can see your name in the attendees list here. And so at some point, if you choose to speak, we'll have to have you also identify yourself so that we know your voice. I do want to let folks know we've got a ton of materials posted on the webpage. This is the first time I actually get to look at the webpage during a meeting. We have the data tables and a variety of reports are on the main webpage, and that includes data tracking for the refuge through December. It includes provisional Shark River Slough data through December. There's a final Shark River Slough tracking report for water year 19 because of us recently getting the final data from the USGS. There's a Taylor Slough and Coastal Basins tracking report. And then there's also on the main page a section called Fourth Quarter 2019 that includes the reports and the QA reports. And then you can click on the link for the read-aheads. And I'm not going to read off all of the read-aheads, but all of the presentations that you're going to see today, the draft notes from the last meeting, and all of those items are posted on the webpage under read-aheads. And then, let's see, I think we can get started. You can hear me flipping papers. I apologize for that. I'm just going to look one more time on the attendee list. Okay. So why don't we go ahead and get started. Does anyone need to modify the agenda as we currently have it posted, which is to approve the meeting summary, go through the fourth quarter report, the final Shark River report, further discussion on Shark River Slough, and the Appendix A subteam update? Any agenda changes? Okay, I'm not hearing any. So the next item on our agenda is to approve the meeting summary from February meeting. That was posted and it was sent to the reps. I understand we have a minor correction we need to make. Maybe Donato, you...
I would not call it a correction. While I was talking, giving my little discussion about the project that we're trying to ensue down at S333 structure, it seemed like when I said 2016, the teen part didn't come through, so it came off as 2016. is how long we've been evaluating that. I wish we had been evaluating this since 2006, but no, it's only been through 2016. So I don't know if that's a correction to the notes. I don't know if they should, I don't know how you want to do that, but it should have been 2016 and not 2006.
I'm okay with making that a correction if everyone else is. I think we'd rather have the correct information posted out there.
Sounds good to me. Thanks.
Any other comments or questions on the meeting notes? Anybody want to make a motion to approve them with the minor correction we just discussed?
Judy, this is Dan Crawford. I'm making a motion to accept with that change.
This is Donato. I second that motion.
Anybody opposed? All right, so we got meeting notes with a minor change. Thank you very much. I appreciate it, everybody. Let's move on to the next agenda item, which would be the fourth quarter settlement agreement report. So John Madden is going to give us an update of the time period from October through December of 2019. So take it away, John Madden.
Okay. Okay, I tried to bring up the quarterly report October to December 2019 on the screen, and can you hear me and see that?
Yes, and yes.
Excellent. Okay. So we have several reports today to go through, and some of these time frames overlap, so I'll try not to be too repetitive. And I will try to remember to pause long enough for questions along the way, and try to keep my eye out for hands raised from the panelists or other persons of interest, but I'll try to get through this presentation maybe, and then we'll do questions at the end if possible. Okay, so we're going to be looking at the 12-month periods for Shark River Slough and Taylor Slough coastal basins ending October, November, and December. And we're looking at the individual months of October, November, December for the refuge network. We'll go into each in a little more detail, but essentially we have 14 stations in the refuge we monitor, and this slide summarizes the geometric mean phosphorus concentrations of those. I think I can get a laser pointer up here, although I can't see very well. That's not that one. There we go. So in this top box, we're looking at the refuge sites, and for this period where our geometric mean TP concentrations for each month are far below the long-term levels that are calculated based on these stages. So we're looking in good shape for this period. The Shark River Slough, this is adding on to the period for water year 19. So this first month, for example, includes 11 of the water year 19 months, and then adds one for water year 20. Of course, this is a tracking mechanism, and at the end of the water year, at the end of September, the water year concludes, the federal water year, and the real compliance test is done based on only those 12-month periods. So we know we had exceeded the limit for water year 19, so we're still here seeing data that the TP flow weighted means for method 1 and 2 are above the respective method 1 and 2 long-term limits for those periods, and that continues throughout those 12 months periods ending December. For Taylor Slough coastal basins, as usual, we are far below the 11 part per billion fixed limit in that area, and at about 5, slightly over 5 parts per billion for water entering Taylor Slough through those sites. So to focus on the refuge, this slide that we present, the shaded background indicates the stage, the 3-gauge average stage each month that we go out and sample. And the red line is the long-term level. That's the target or the limit that we have to meet. And you can see for majority of the period, the blue dots representing the geometric means are below that limit. And for the recent period, we've been quite a bit below that limit. The 36 months that's shown on this slide, the average of those dots that we've measured is 6.9 parts per billion. This following slide shows the same information, but that limit, the long-term level line, has been stretched out to a flat line, and this just shows the difference between those. So again, for since February of 2019, all these months are considerably below, and overall for the 36 months, we're almost 3 parts per billion below the long-term level. And then I had shown you these 3 months, October, November, December, looking at the preliminary data. The positive trend continues, and we're about 3 to 4 parts per billion below the long-term level with our observed data. And we can see the stage in April has started to decline somewhat. So we were only able to sample at 11 of the 14 stations. The other were either dry or the water level was too low to sample, less than 10 centimeters. Now I'll move on to Shark River Slough tracking. I had explained a little bit on all these numbers and how a lot of this period is still in water year 19. I didn't mention the flows overall are still fairly low. It's been, even prior to water year 19, we had some low levels, low water levels coming in. So it's been somewhat dry, and the overall volumes to Shark River Slough have been a little low. And the other thing to note is that our percent of sampling events that are greater than 10 part per billion, the observed levels here in most cases, well, it started here, we exceeded, and then through 12 months through December, we're close to or exceeded the guideline for those. So we're seeing a lot of events that are above 10 parts per billion. Remind us, I'm going to go into more detail in a following presentation or two on water year 19, so I'm not going to dwell on this, but both methods did, the flow amine concentrations exceeded the limit slightly, less than a part per billion. Looking at the flows, we can see for the 36-month period ending December that a few things have kind of changed over this period, but we see the cycles of wet season, dry season, and the severity of those, of course, varies. And the pattern started to include some of this yellow, which represents the S356 pump station. So we're seeing a lot more utilization of that 356 station in the recent periods. And for this period we're reporting on, it was very low input from S12A and B, which are the lightest blue. And as we go up, C and D, again, had some input, but not nearly as much as the 333 site, which is the dark blue. And this can be seen on the following slides as well, a little more individual magnitude based here. As I flip through, and this really highlights that 356 has been able to be used more under the current conditions and increment 2 operations. Zooming in just on the L29 segment east of S333, we have several potential inflows and outflows. We have the dark blue, it's the 333 water coming in, the volumes. The yellow is 356. And this orange trace shows how much of that exits through 334 and does not go to Shark River Slough, but anything above that orange line goes into Shark River Slough. So this large volume of water here really comprised most of the flows for the recent 12-month periods. And overall, looking at the sampling events for the 36-month period, we see pattern. Again, the blue bars are the flow. This is the entire combined Shark River Slough compliance calculation. And the yellow dots are the phosphorus levels. We'll see this type of chart often, but today I got it. But we have a super high spike back in water year 17, water year 18. We had a little bit lower spike, and there was only very little flow associated with those higher numbers. And then the more recent periods, we see a more wide, scattered, not as acute or high phosphorus levels, but prolonged and with a little bit more flow above, again, that 10 part per billion level. And this is those same phosphorus samples tracked with the moving 12-month flow-amine concentration for Shark River Slough. This is where we ended in the most recent 12-month period. Taylor Slough coastal basins, we have 3 methods of computing the flow and flow-weighted mean based on numerous structures that had been added recently. Our historic method 1, we're ranging 5.3, 5.2, and then the others are a little bit lower. They incorporate some structures that are discharging directly into Shark River Slough, including G737, and method 3 incorporates S328 as well, which is downstream of the 332D pump station. And our observed percent of sampling events greater than 10 parts per billion is very low. The historical annual data shows we're far below the 11 part per billion limit in this area. The distribution of flows between the structures on a daily basis for the last 3 years is shown on this plot. 737 is downstream of the S200 pump station, and you can see that's been utilized somewhat. And the 332D on the bottom plus S18C. As I mentioned, the S328 structure is downstream of that and the 332D site. Again, very little at DX1. That site does not go towards Taylor Slough coastal basins. It moves flow into the south detention area, which is north of the 332 detention area. So looking at the detention area itself, 332D coming in is the bluer, and then 328 is going directly to Taylor Slough coastal basins, to Taylor Slough, I should say, downstream of 328. Similar looking plot. We do see every once in a while we had these events. These are usually higher. These were associated with tropical storm or events back in the previous water years, but we've been pretty consistently low and kind of consistent flow for the recent period. Similar tracking here, and you can see at a point in time when the 12-month period that included, I believe this was when Irma event back in September here, dropped out of the 12-month rolling average, then that kind of returned back to the levels we're seeing now, around 5 part per billion. And that is what I have to present for the fourth quarter of 2019. I'd like to open it up for questions.
Thank you, John. Anybody have questions for John?
No,
I'm not hearing.
This is Donato. I don't have any questions. I just want to thank you, John. Just looking at these new flows that we've been incorporating and actually seeing how they're distributed out here in this presentation in this simple, clear format, it's a big change from working with this stuff on a daily basis and looking at them, day by day. And so it's good to see how much impact this is actually having. The 356 is returning flows, and it's starting to really show up clearly. So I like to see that. Thanks, John.
Very good. Agree. Okay.
Any other comments or questions for John on this particular item? I'm giving everybody a second to unmute themselves if you're ready to talk, so I'm just letting you know that. All right, so John, I think we're good to go on to your next item. So John's now going to present the annual final Shark River Slough results. Go ahead, John.
Yeah, we're actually backing up 3 months, and these are results that are ending in September of 2019. And since our last meeting, we've received the final flow data for the S12s that has been confirmed by USGS. There were very slight differences, I think 1/10 of a part per billion here or there. Didn't really change the results. We're, again, focusing. This table was previously presented in February, and the report was posted for the February meeting. This middle section for Shark River Slough has been updated just to reflect those slightly different flow numbers, which affected the limit and the fluid mean concentration. So as I presented on our previously, our 10 part per billion measured TP flow wave mean under method 1 is slightly higher than the 9.7 limit associated with that method, and method 2's 9.3 observed level just exceeded the 9.2 part per billion limit. And again, highlighting the percent of sampling events greater than 10. This year we saw a more spread out. We didn't see as high sampling events in TP, but we saw more numerous sampling events that were slightly elevated. And I'll remind you, I'm actually going to present a lot more kind of investigative, informative information in the next presentation. This one's going to focus on the typical compliance reporting data only, and it is a bit repetitive, so I'm not going to spend too much time. I'll take some questions if you like. The results again are repeated several times different ways. As I had stated before, we see 333 and 356 taking a lot of this last period. So the water year 19 began, I lost my laser pointer, I'll bring it back up. right about here, so we can see as the water year ended, actually S12A and B were closed. S12C remained flowing for about a month, as well as D, and 333 and 356 were flowing for that month of October, and there was a period of flow at 355B where temporary pumps were installed as well. And that really came to a pretty quick halt after 1 month into the water year 19. And we can see majority of flow from that point on was through 333 with some other additions by 356, and finally the S12s in the last couple months of the water year. This information is just displayed in a different manner on the following slides. There's no flow at 355A, and here's that one little period of flow at 355B early in the water year. Looking at the L29 segment, what came in and out from those areas. Again, our water year 19 is starting right here. So we had significant flow for a period. And then a lot of this flow during the November through even June period, all that's under this orange line is being sent around the corner down the South Fade and not in a Shark River slough. What you see above that was counted towards the compliance. And then pretty much 100% of the water that entered that segment went to Shark River slough in June, July, August, September. A significant contribution, as Donato emphasized, from 356, which is returning a lot of seepage water from the eastern side, as well as some deliveries from the conservation area via the eastern route. Our sampling events. This is again the 3-month period ending September. So we talked about some of the patterns that have been seen. You can see go from a very sharp high spike in water year 17, water year 18 as the wet season onset came. We had some less severe concentrations, but more of those. And then kind of that pattern we saw this year where we're delivering water through 333 primarily during this, February, March, April, May time period, and concentrations were a little elevated between 10 and 18, and we had a couple at 19, and it wasn't until later in the water year when those concentrations came back down below 10 parts per billion. Similar here, as the water year progressed, we can see the 12-month rolling kind of creeping up, and this is where we ended up for water year 2019 with those numbers that I indicated. So I don't know if we want to go into much for detailed comments now, considering that my next presentation is very focused on the same period, and I'm going to be giving some information for stage and upstream concentrations and some of the patterns we saw with more detail, but I'll still be willing to take any questions on the data presented in this presentation.
And this is Julie LaRock. For those of you that aren't as familiar with the process here, we do have the final numbers now for Shark River Slough, and we're showing that there's an excursion. So the next agenda item is all this additional detail that John mentioned. So does anybody have any specific comment or question on what we just saw, or shall we launch into the next item? And welcome to the meeting, Mr. Barquette. I see you're on the line. Thank you. Okay, John, I think you can move on to the next agenda item. So John's now going to take a look at some other things and what actually happened in more detail during water year 19 so that the TOC can start considering our actions, recommendations associated with the excursion.
Precisely. Thanks, Julie. Some of the graphics may look familiar from previous water years. Tried to focus on the things that appeared to be important or significant, kind of mirror some of the things we've seen in the past. Remind you, these are the values that we're talking about this 12 months ending September 2019. I thought I'd throw everything at you right at the beginning here, but I'm going to go kind of step through this, and we'll wind up on this slide again later in the presentation. We're going to talk about the stage in the conservation area. Let me get my pointer again. So we're going to talk about the stage that throughout the water year in the conservation area. This is a 3-gauge average. We also have the stage in these purple dots that was right in the canal upstream of S333. The S333 weekly concentrations in these orange stars, and I'll go into detail on why we're really focusing on the 333 concentrations, not overall Shark River Slough. In green, we have a value called TSS that we monitor at the same point, total suspended solids. So that's everything that won't pass through a certain size filter when we sample. So those are particles that are in the water. And we can see some correlation between those definitely and the phosphorus levels. And then the flows, we're going to integrate the 333 flow, and then the portion of that along the bottom that goes through a 334. So we're going to look kind of at why all these different pieces of information are important to consider. Looking at a little history of stages. These are the same two flow, and this is the overall concentration across Shark River Slough, all the structures. We presented a slide similar to this in the past, but this is showing all the way from water year 14. These water years in red are the water years where we had a technical exceedance, meaning the flow-weighted mean annual phosphorus level for Shark River Slough was greater than the long-term limit computed by the equation in Appendix A. And water year 19 is the third in this period that we saw that. Although we see somewhat similar seasonal patterns, each year is unique. And these last 3 years are the ones that I had shown you on the previous slide, and we're going to continue to focus on the last 3 years just to not overwhelm ourselves or anyone on looking at too many years all at once. It's just a reminder of where we've been, what we've seen, and looking at here flows and stage for water year 2017, 2018, and 2019. Stage is definitely correlated with flow. We see more flow when the stages are higher because we have to get the water out of the conservation areas. There's a regulation schedule, and formulas that are used to determine that. But we can see little differences. This 9.2 reference line is just to help you guide your eye kind of across from the stages here that are shown on the right. So that 9.2, when we see, it's not a 100% hard line, there's some flexibility in there, but when we see stages below that, we tend to see our higher phosphorus levels. I'm going to show the phosphorus on the next slide, but we can see that we entered water year 17 quite a bit above that level. Well, about a little over 10 and a half, almost 11. The water year 18, which we met our phosphorus limit, we had much more flow early in the water year when stages were high. You'll see that's a kind of a recurring theme. And we had kind of more prolonged period with stages just over the 9.2. Quite a difference from what we see here in water year 19. We never really had much volume come in at the early part of the water year. Our stages were low. We started at about 10.5 for the 3-gauge average and below 10 at the headwater of 333, and very little flow getting to Shark River Slough early in the period. This 333, by the way, is the net 333 that goes to Shark River Slough. So it excludes any volumes that were sent down to South Bay conveyance. So we're hovering above and below this 9.2, and the 333 stages are below it for a lot of this period when we did see flow through the S333 station. So as we add and go to the next slide and show our stage and the phosphorus levels, the same stages were on the previous slide, so we put them a little in the background, but what you'll see are, I'm going to simplify this in a minute by getting rid of some of these, but I first want to show all the sites, 12A, 12B, 12C, 12D, and 333. The primary conditions for these water years, and I did not include 356 on this slide, but those phosphorus levels are pretty consistently low on that side as well. That'd be a consideration for the future from that data as well. Another thing on all these traces here with the concentrations, if it's large enough on your screen, you may notice that some of these are open symbols and some of them are filled in. The ones that are filled in and solid are representing when there was flow at that site. So really all this S12A data where it does increase, we collect phosphorus levels every week at S12A regardless of flow. At S12B, C, and D, we only collect on flow typically. So despite these levels being high at S12A, which is far west and along Tamiami Trail near the western border of WCA 3A, there isn't flow associated with these. And there is flow occasionally with 333, and when we look down at water year 19, you see a lot of flow at 333 throughout the water year. So on the right, we can see the concentrations associated with those with flow. So these are flow-weighted mean concentrations. They don't consider at all the dot, the circles, the symbols that are not filled in, and they weight the sampling events with the highest flow with the most. So overall, the Shark River Slough for water year 17 is 9.7, but we can see the distribution concentration much higher at 333 for that water year. Similar pattern, but not as high concentrations, 333 for water year 18. And interestingly enough, the concentration at 333 was only 11 parts per billion for water year 19 for those flows that went to Shark River Slough. But that overall flow weighted mean of 10 parts per billion was still high enough to exceed the limit. And there was not as much flow at S12A, B, C, and D that we saw in the previous to kind of counter, bring that overall Shark River Slough concentration down. So the next slide, I'm going to focus on just the 333 and kind of get rid of some of the clutter of all these sites that didn't have flow, and when they did have flow toward the end of the water year, they're pretty low and matched pretty closely with 333. And I'm also going to introduce a depiction of some upstream stations, the inflows to the conservation area, and we try to focus on those that will have an influence on the 333 concentrations here down at the southeast end. So I divided the inflow sites into two groups. We have western inflows and eastern inflows. We know the western inflows are forced to go across the marsh, and by the time we get down, and it mixes with Mullet Slough inflows, we have S140, S190 flows that end up coming down the Interceptor Canal. All in southern 3A, the marsh, we see concentrations that on an annual basis, we're seeing 3, 4, 5 parts per billion, very low. So we're considering these eastern inflows either directly from the STA facilities and those upstream canals, or those that go into Conservation Area 2 and then through the S11s into Conservation Area 3. We also have inflows from the S9 pump station and S9A that serve western Broward County in that area. And we also have a portion of flows that come down the Miami Canal, and there are two structures, 339, which is kind of hidden here, and 340. Those are typically closed, but when stages get high in this area, releases are made through those and come down the canal. So I've included that data as well. So all these eastern inflows will combine to, on the next slide, where we see a trace for inflow flow weighted mean. And again, for each water year, we see the stage, and the black plus signs are the inflow flow weighted mean, and then we see the 333, these stars. And overall for each water year, we can see that 333 compared to the eastern inflows, the flow weighted mean in the last 3 years was 11 parts per billion, 10 parts per billion, 11 parts per billion. It was not a compliance calculation. It's just an indicator of some relative values. We can see that the water year 17 exceeds this data point was a big factor in that. We identified that, and finally the TOC decided it was extraordinary natural phenomenon in that time period. But the phosphorus levels returned quite low after that. Water year 18, we saw numerous concentration events at 333 that were higher than the inflows. Sometimes we do see, a weather event this time may cause 333 to go up, but for some reason the inflows are actually lagging behind that or after that. And sometimes we don't see really a reaction from the inflows, but we see it at the downstream. So focusing on water year 19, coming in, we're pretty flat and matching relatively closely. Here early we had a rise in TP concentrations, less magnified at the upstream stations, but we saw it at S333. Didn't really see commensurate rise the inflows in June. I can explain these couple points are an auto sampler. I won't spend much time on it, but there was one value at S9 pump station that influenced those, and there were like 2 or 3 days with flow at that point, although personally I'm suspect as to whether that data is valid since the grabs and auto samplers before and after that period were really low, but we showed them on here not to exclude any data. I think I made the points I need to on this slide. I spent too much time. So going back to these plots with 4 axes and very many data points on them, I included 3 for water year 17. So this is water year 17. We're going back in time a little bit. Again, the high event, both flow and TP concentration at 333, and to remind you, the total suspended solids value that also spiked. Usually our total suspended solids is close to undetectable. It's a level that we don't measure below, but we do see it spike up from time to time. And again, these water quality samples are strictly at S333 location. Water year 18, a little different pattern. We had much higher stages. Again, you can see better on this. The stage is a little more visible, where we started at 11.5 in the canal, about 12.3, and even exceeded 12.5 in the conservation area, the 3-station average. Then the decline and the little spike. Again, our TSS went very high. Phosphorus during this event at 333 was around 55 parts per billion, then dropped back down. Water year 19, everything is much more compacted towards the bottom of the slide. Our stages were below 10.5 in the marsh, just above 9.5 in the canal. We saw a good amount of flow, both through 334 and then some to Shark River Slough during the dry season. And no huge spikes in concentration, but we get up to over 30 parts per billion at 333. This was in June. I think the next slide I can look at those specific events. We're getting there. A little bit different way to look at things on this slide. We included only the compliance sampling events here. And so instead of showing daily flow, these are kind of blocky, but in the background you can see this flow is every bi-weekly event that counts for compliance. We plotted the flow. And then we, in the yellow dots, with the concentration, and then the stage. So these are really the essence of the compliance calculation. So at the bottom, just trying to ascertain, what time periods or events were significant towards that compliance. We plotted a difference between what the phosphorus flow weighted mean, the TP flow weighted mean accumulated just for this water year for Shark River Slough is versus the limit. So you can see when we, for example, after these first 3 events, after the 3rd weekly sampling, we had accumulated a flow that gave us a limit difference from the flow weighted mean concentration of these 3 events of about 6 parts per billion. So actually the flow weighted mean was 6 parts per billion below the limit. And as we progress, obviously when there's no flow, it doesn't really change. We saw a little jump here. And as highlighted, this is March 5th sampling event, and we went from 5.3 parts per billion below the limit to 3.5 parts per billion. And this flow event, 100% of that flow was at 333, which was about a little under 1,000 CFS. and 17 parts per billion was measured. At that point in time, the stage was 9.11 on that day. So I just highlighted two events where it seemed to kind of make that jump. Another one was June 10th. We went from 1.8 parts per billion below to 0.4 parts per billion below. All the flow again was at 333, and at 19 parts per billion, a little over 1,200 CFS past that structure. And the stage was down to 8.54 in the canal at that point in time. The canal stage continued for a couple weeks near that level, and then we finally got enough inflows and rainfall for the stage to rise back up. And as that happens, the concentrations we can see decline. And actually the concentrations on this side, so I think ended up around 7 parts per billion. And at the end of the water year, this method 1 was 0.3 parts per billion above the limit. It just, in that last period with those concentrations and that flow, it just skirted that zero line and exceeded the limit. I know it's a lot of information. I have 3 slides left, and one of those is kind of a conclusion slide, so bear with me. So the next 2 slides, I have 12 annual water years of data, and these are the 12 years that the long-term level has been effective since water year 2008. They are sorted by the Shark River Slough flow-weighted mean TP, the annual TP in the second column here. So the highest of those was 2014 and proceeding down. Okay. We're also showing as a comparison what the long-term level was that year, the difference between those, and it's red if it's an exceedance. The flow that entered Shark River Slough, so the flow is inversely proportional to the limit, and the rainfall measured over conservation area 3 within that water year period. The 2 lowest rainfall years are highlighted in yellow, and actually those did not have an issue with exceedance. They met the limit by quite a bit. And water year 19 was the 3rd lowest rainfall. So we had a couple years with 39 inches, and water year 19 with 44 inches. And then the next lowest, 2009 had 47, where we just equaled the limit. And then a couple with 49 inches rainfall. So again, the third highest TP concentration was water year 19, so it's ranks 3. I said the 3rd lowest rainfall year. That doesn't seem to be necessarily correlated to anything, since those were the lowest rainfall years were not higher. For inflows, which determine the limit, this water year 19 was the 5th lowest within this 12-year period. One thing that I don't have in the table itself, but the canal stage at 333 that had been plotted on the previous slides, the maximum stage during the year was the lowest of all these 12 years. So the highest that the canal got during water year 2019 was the lowest on record. And also the flow-weighted mean stage. On some of those plots I had mentioned, you see how much flow occurred during this period where the stage was low, or during where it's high. So if you weight all those by the flow, water year 19 has the lowest flow-weighted mean stage. And this table has those same 12 years with the same ranking by the inflow TP flow weighted mean, so they're in the same order. but I'm showing some concentrations, the annual concentrations at each of these 5 major structures for inflows. And the shading is not really, it's just kind of arbitrary where the cutoffs are, but you can see the light green or tan are the lowest concentrations, and these pink are ranging from 7.7 to 9.2, and then the orange are above 9.2. So these values, S33 consistently, there's only one water year where 333 was not the highest TP flowway mean concentration for the year. Overall, for these water years, averaged 13.7 parts per billion versus the other all being below 9. And the last column shows what percent of the flow for the water year went through 333. So knowing that 333 has the highest concentrations, even though 11 wasn't really didn't rank very high for 333 itself in this record, 63% of the flow went through the 333 and 2 Shark River Slough. So 63% of the water to Shark River Slough was delivered through S333. So the next step, as I understand, for the TOC is to consider this water year and a few questions. Julie can cover in more detail the specific questions, but we look to see if there's a data error that may have affected the compliance. And we've looked at that, and there was no apparent data error for this period that affects those results. When considering extraordinary natural phenomenon, which is another question that TOC panel will need to consider, it's not clear how extraordinary or how natural any of these things are, but I'm just reiterating some of the observations we had on the previous slide. So we talked about the canal stage being very low, and a lot of that flow occurring during those low stage conditions. How much flow was distributed greater than 60% at S333. The rainfall is the 3rd lowest in this 12-year period. Rainfall, the previous wet season was also pretty low, so we came in with a low stage. Low stages in the marsh and the canal. Never really got up to a high stage. And, in addition to all the natural, rainfall things, of course, operations can have an effect on that. So just as a reminder, water year 19 was the first full year under increment 2 operations officially, which allows the stage to go up in the L29 canal segment and really facilitated some of those flows through 356, which again are low concentration inflows. So that's what I have for slides. So I'm going to pass it back to Julie or entertain questions.
Yeah. If I could, this slide here, John, is a really nice segue into me, reminding our TOC representatives as well as folks listening on the phone. So our process for this is, first of all, to take a look at whether or not we have sufficiently evaluated the relevant information for a better understanding of what might have caused this exceedance. And then secondly, has the TOC determined there's substantial evidence that the exceedance is due to error or extraordinary natural phenomena? And we were asked and agreed some years ago to, review trends for flow-weighted means and frequency of samples exceeding 10 and other information we find to be relevant. And I'm hoping most of that was presented here by John. And if we do answer those first two questions, we would then proceed on to apply Appendix C to consider what additional remedies would be taken or we recommend be taken if we determine it was not due to error or extraordinary natural phenomena. So I just want to remind everybody of that part of the process. I do also want to call on technical staff here at the district first to add anything that might be relevant to John's presentation. So I think Stuart had some additional comments. So let's go to Stuart for technical staff, and we will hear from other technical staff associated with the group and have some discussion with the representative. So Stuart?
Wait, I'm sorry, Julie.
Yeah.
You're letting John off the stage. I thought we were going to get a chance to ask some questions first.
Oh, okay. Yeah. Go ahead and ask John some questions, and then we could have Stuart. I apologize.
I don't have a bunch of questions. I do have one, which is what drove the selection of this period of record to evaluate the rainfall and come up with the third highest or lowest rainfall for 3A? What was that driver for selecting this period? Why didn't it go further back in time?
We were evaluating the annual versus the long-term limit. That's when the long-term limit applied. So, right, a more thorough climate analysis for rainfall could be performed that would include more years.
Okay, thank you.
Okay. Other questions for John?
Hey, Julie, this is Frank with DEP. I've got a couple of questions trying to go through the data. This is the first time I had an opportunity to look at it. So thank you, John, very detailed. So the positive thing, I think, is seeing that water is moving through the S333 upwards of 60%. And you don't have to answer, but I thought there was the acknowledgement that for modified water deliveries and future operations that the S333 will be utilized, or that system will be utilized more often. That's kind of one of the goals, is to increase the flow less on the S12 side, more on the eastern side through the 333. So is that, am I on track on that?
Yeah, that's my
Frank,
understanding. Maybe Dan can answer.
Yeah, Frank and John, yeah, this is Dan Crawford, core TSU rep, and yes, I agree that the priority under the Modwaters field test, as well as the combined operating plan that we're anticipating starting in late August, that the first priority is to send the water to the center part of the historical Shark River Slough system, which is through 333.
Good deal. So we may have to go back to a couple of those slides, John, to look at the ones particularly with it showing the March and June, that one right there. You just passed it. The one, there we go. The March and June event. Did we happen to look at any type of rainfall event that occurred to increase the stages prior to this March sampling event and June sampling event? Or was it throughout the entire conservation area, or was it just localized in this particular southern portion of conservation area 3A?
I don't know.
Can't you just go back to the other slide where you have the S12D on there? And
yeah, so, well, first of all, I guess we can look at the pattern of the inflows. No, we don't have the inflow flows, but I don't know the severity of the rainfall at those particular points in time or the location where they were concentrated, Frank.
Gotcha.
Take that down as something to look into.
Right, yeah, I mean, that'd be interesting to see. So TSS, right? So where does TSS come from? I mean, is it canal-based or is it marsh-based? Do we have an understanding of that signal of or correlation analysis between TSS and phosphorus concentrations being elevated?
I don't think we have evidence as to the specific source on those measurements. Okay. But maybe there's some ideas that can be discussed.
Sure. So,
John, this is Bill Walker. Yeah, I had a question on the TSS versus phosphorus as well. I mean, as I recall, historically, there have been really two hypotheses. One is that there's some scouring of the sediments from the bottom. And the other one is that there's algae growth in the canal that's, buoyant and comes up during these stagnant water periods, and then it gets flushed out. And it's been a while since I looked at it, but I think the second hypothesis is, something that needs to be explored more. But I think I ran into a problem because the chlorophyll measurements in the canal stopped at some point, and I don't remember exactly when, but between those two mechanisms, what can you do about it? You've got bottom scouring, and people have talked about changing have changed the outlet design. I don't know if that's going to work or not, and the algae growth, there's always been enough phosphorus in the canal to support the algae, but you might also be looking at like global warming. Look at the temperature, look at the oxygen percent saturation, and see those metrics would be correlated with algae. So I don't know how much of that's been done, or I don't even recall exactly how much I've done in the past. I'd have to review it all. But anyway, those are some ideas on that.
And we may have some feedback. This is Julie from some other folks on that. I know Donato mentioned a study that they were doing. I don't know if that includes anything. So thank you, Bill. Those are really good thoughts. Stuart, I think you had some additional comments you wanted to make on the presentation itself.
Hey, Julie, I've got one more question. I'm sorry, this is Frank again with DEP.
Sure.
So, and John, thank you for looking at a bigger picture of the conservation area when the inflows and outflows of the conservation area 3A. Did we happen to look at the same time period of the March sampling event and the June sampling event, if there was a similar signal in the ambient water quality stations and in the S152 station, or like in the S12D, looking at that comparison analysis to see if there's something occurs when obviously the stage of the canal gets below 9.2 or the headwater of 9.2, and it appears that there may have been some type of rain event, that a re-wetting occurred to, elevate the phosphorus, the TSS, and as what Bill was saying, maybe temperature and other correlation analysis that needs to be done with this. Just trying to get a better understanding, a bigger picture than just a 333.
Right. So as you're alluded to, we do have monitoring on 152. I don't know if inflows were occurring at that time, but I can look into that. And then the marsh stations, we did not track that. There may be some point in time when the ability to monitor the marsh stations, if the water levels were low enough, was not there. But that does seem like it would be helpful even to know that sampling wasn't done because the levels were too low, and then what the levels were when it came back up. So thanks for that suggestion.
This is Bill. I have another question. Go on the last slide.
The last slide. Conclusion.
For the benefit of all of our listeners, Bill is working with Donato representing the park, by the way. Go ahead, Bill.
All right, extraordinary natural phenomenon. I mean, I think what's listed on that is really obviously a hybrid of the natural with the rainfall and so forth, and then the operational impacts. And in analyzing the increment 2 operation under COP, we predicted that there would be an increased risk of excursions with that operation mode, because 3A marsh is drawn down lower, and that tends to generate phosphorus spikes. But on top of that, you've got this really low rainfall, so it seems like you've got kind of a perfect storm here. But it's not. I think it's totally consistent with the type of analyses that we did for COP, and so. The question is, to what extent in the actual implementation of COP during this period, there were some recommendations made, to kind of modify the operation with adaptive management to try to reduce the risk of an excursion. And so I would think that the kind of analysis that would be useful would be to figure out, to what extent were the adaptive management measures implemented during this period? So that would give us an idea about, whether something more aggressive moving ahead in terms of operation might help to reduce the risk. So I know that's a lot of work to do, but I know that people have been tracking this, so hopefully that would be useful.
And hopefully we can kind of divvy up those homework assignments here, Bill. So thank you.
Yeah.
Hey, Julie, this is Frank again. I got one last statement, and I apologize, Stuart. I know you want to get the floor. So looking at the hydrologic data right now within Conservation Area 3 and looking at the structures currently in this water year, it appears that we are in a very similar situation than that we were last year, right before a re-wetting scenario occurred. And my understanding, you guys may get a lot of rain this weekend, and there may be a compliance sample next Monday. I just want to have a better understanding of, we may have an opportunity to explore some of the things that we're talking about in the current stage of the stages of the conservation area and headwater up 333 and other surrounding stations. Just want to point that out.
Okay, thank you, Frank. And that kind of ties back a little bit to Bill's comment, I feel. So.
This is Donato. I wanted to follow up on Frank's earlier question about a regional look. I don't have control over the screen, so I can't show you my slide. But I did put together side by side the S333 151 going back in the past when it actually was collecting and flowing, and then the S152. And looking at the grab and auto sample S333 all combined together, this peak that happened, the 2 peaks that happened in this water year 2019, they're not mimicked by the 152. They do slightly increase, but they don't come anywhere near the magnitude that we're seeing down at the 133.
Oh,
I can send that out if that helps, but I don't know how to demonstrate that right now, but I'm looking at it clearly right now.
Okay, thanks, Donato. That's we appreciate you looking at that.
Yeah, thank you, Donato.
Yeah, Julie, and this is Dan Crawford. I know Stuart wants the floor. I would just add as well, I think that, the citation on here looking at the lowest water year canal stage, I think that, the slide earlier, John's earlier slide indicated that was at the 333 headwater. And, to Frank's point, since we're using 333 as the primary delivery mechanism, we would expect to see some localized drawdown at 333 headwater associated with increased use of 333, and particularly now that we've raised the L29 canal stage up to 8.5 with increment 2, as per the last bullet here. So it's probably useful to also look at stages further north than just the 333 along the L67A canal to see if that trend continues. And just a quick look at that through DB Hydro, I don't see that same trend evident. Like if you look at the site 69 West, that's 10 miles upstream, but still kind of in the area of influence. So I think it's appropriate to make sure that those statements are appropriately caveated, and we're not just looking at local, we're also looking at kind of the intermediate scale when we're talking about water levels. Over.
Okay, thank you. Other comments from the reps, and then we'll get to Stuart.
Hey, yeah, so this is Lori with the Refuge. And John, thank you again. You did really kind of zoom in on some localized areas, and I really like the way you put your graphs together with some additional information. So again, I know that's a ton of work, and thank you so much. When I'm looking at this slide, I guess the first thing that I see is that rainfall patterns is a critical missing piece of data. You know, looking at rainfall over an area versus also looking at rainfall kind of in the S333 area. And then looking at this slide, a couple of things jump out at me. One is, you know, the verbiage about low stages, low canals, and low rainfall. Yet we have increased 333 flows of 63%. I'm not sure quite when. I'd like to look at a little bit, have a little more time to spend with that. So I guess two questions kind of jump out at me is this a localized issue? Because we've talked about the S12s, we've looked at those, we've now heard about the 152, the 151. So it's sounding to me like it's kind of a localized issue. Oh, and then number two is, could this be an operational issue maybe? So I don't know, those were the kind of what I took away from this slide, and just kind of raised some more questions for me.
Okay, thank you. No, you guys all have good questions. I appreciate that. Thanks, Lori. And I've kind of noticed some of the same comments that some of you guys have also noticed. Anything else from the reps, and then we'll get Stuart, because I think he wanted to add something, some technical commentary here. Stuart?
Hey, Julie. Hi, all.
Hi.
I can't see the screen anymore. I was logged in through VPN through the district, so I just lost the Zoom connection. But what I wanted to do is, now it's a little bit out of order now with all the conversation that's gone on, but I think it's on slide 7. If John could go back to that one, related to the map of Water Conservation Area 3A with the eastern and the western flow areas. So let me know when you're there, John. Can you all hear me?
There we go. Okay, we're there.
Yeah, sorry, I overshot it a couple times. There's a little lag here.
Okay, is that the right slide, slide 7?
Yes.
With the map.
Okay. All right. So, I mean, first of all, this is a great presentation that John put together. There's a lot of information that goes into these things, and you know, week after week while we were working on the presentation, there were a lot of types of information that we were looking at to try and include and be as inclusive as we could, knowing that you can't throw everything, you know, the kitchen sink and everything at it. So we tried to take an approach which covered many different bases. And this particular slide was one that we had discussed to insert in there, along with, I think it's slide 8, that has the upstream concentrations for water years 2017, 2018, and 2019. And we inserted these because in years past, we have discussed and talked about verbally about upstream conditions when we've evaluated an exceedance downstream, as we did in 2014 and in 2017. These exceedances is Shark River Slough. So we had previously looked at information, but we thought it was important to show the information this time so that when the TOC does get into following the three-step process that Julie talked about earlier, the first step is, have you looked at all of the data? And then, so we thought it was important to be able to look at the upstream inflow and try and give some idea of what we're seeing in that data. So as John had said, that the western inflows, we know that STA 5.6 still has a ways to go to achieve its Q-bell limit. And the Q-bells are in place so that we make sure that, in addition with the BMP program, that as those flows are going through the STAs, that those flows are at the requisite level so that they don't further cause or contribute to violations of state water quality standards or to violations in the refuge or in Everglades National Park, Shark River Slough in particular. We know also that we have to deal with state water quality standards in Area 2A and in Area 3A. That's a lot of times why in presentations that the district gives that we show the marsh concentration. And for the western inflows, we know that from the western basins, those elevated concentrations are causing local impacts in 3A on the western side. We know that STA 5.6 still needs to discharge at a lower level to attain the Q-bell. We also know that as that water flows through the marsh, that it may be an issue for water quality standards for 3A under the state's phosphorus rule. But when you look at that, when you look at the information and you see what's coming across the marsh, one could conclude that the concentrations, as it does move through the marsh, that it does not seem to be impactful to Shark River Slough. So therefore, John was saying about the eastern inflow. So we know that STA 3.4 for many, many years now has been discharging at or below 13 parts per billion. So it's, in all practical ways of saying it, it's been discharging at or below the Q-bell level. That's a huge inflow into water conservation area 3A, with the discharges either going to the S8 structure or they can go into the S150 structure in the northeast corner of 3A through S150, or it could even be pumped some volumes S7 into water conservation area 2A. Now we know that STA 2 also has a ways to go. It's the second best performing. So its discharges going into 2A in the northern part of 2A are impactful for 2A itself. And as John has shown, when you look at the information together coming through S150 and what's being discharged through the S11 structures, which is a much lower concentration, and you combine that with what's coming out of S9, that seemed to be a good way to be able to evaluate the eastern flows, which might have, would be something that we would want to look at to see whether or not there's an impact on Shark River Slough. So with what John showed, that the eastern inflows, when you look at them, coming through S150, coming through the S11s, coming through S9, you look at it in how it's all aggregated and look at the time series over the year, it doesn't appear really to have a signal where those spikes are occurring downstream in Shark River Slough. So it seems it's something important to look at from a technical perspective, because when you get to the next questions on remedies, if that is the place where the TOC goes, because you're having deliberations on extraordinary natural phenomenon, rainfall, maybe there's more evaluation that needs to be done in that respect, like Donato and John were talking about. But it is important also to acknowledge that in terms of what we're seeing from those upstream influences, that when you look at the data, it doesn't look like those upstream influences are a dominant factor, if at all. And everything that we're talking about now are these interior 3A mechanisms, and Bill talked about a little bit about chlorophyll levels, what's going on in the marsh, canal interaction, maybe we need more monitoring. So we seem to be at a place, when you look at the technical data, that the conversation has led us over the course of a number of years to be focusing interior downstream in 3A and not so heavily focused on the SDA BMP program of what is going on there. So that was just the additional detail of why we thought it was important to put that in there, is just kind of, look at all the different angles. And so it doesn't, so it can help in part of the conversation as you all move forward. So that was it. Thank you.
Stuart, this is Bill. I have a couple of questions. First, in terms of the effect of the external inflows and the STA performance and the BMPs, you kind of ended up with saying, well, they're not important, and therefore it's operation or natural, like algae growth. But I think, there's an intermediate scenario there, is that, that has to do with the loading of the soils and the vegetation in the water conservation area, so that, that it's still, I think it's still in a system where you're getting some gradual leaching of of those historical loads, and those show up as, in long-term trends, long-term decreasing trends in concentrations. It's been a while since I looked at those trends. I know you have, but I don't know, has the district updated their long-term trend analysis? I think that would be important for forecasting, what would be the risk moving ahead, because it could be that the compliance situation will very gradually continue to improve just because of those trends, assuming that the STAs are, some of them are further improved, and so the external loads are controlled. So that's one specific question. Have you updated the trend analysis? Do you have any insights on that?
And Bill, this is Julie. My memory may be failing me here. When you are asking about a long-term trend analysis, what are you referring to exactly?
Just trends at the structures, trends at the S12s, and trends in the 3A marsh, the phosphorus concentration with seasonal Kendall test.
Okay, thank you.
Yeah, Julie, if I may. And maybe John Madden might be able to better address this question, but I know every year in, I think it's Chapter 3A of the South Florida Environmental Report, DEP provides trend analysis at a lot of the, within the Everglades, and that may be a place to look toward, where that data exists. I also know that I've heard that US EPA is in its final rounds of drafting their last remap report, which has a lot of information on their 2014 sampling, maybe a little bit of a lag, but all their soil sampling throughout the Everglades protection area. And I hear that they're going to be putting trends and what the soil concentrations are throughout Area 3A. Maybe that might be another source to look at as well.
Well, I'm not so sure that the EPA, that's a snapshots over long times. It's pretty hard to get trends because there's so much variability. But and the DEP's reporting in the SFER appendix, I think that's mostly related to the compliance. Yeah, I think there's information there, but I was thinking more in terms of just a simple monthly seasonal Kendall test over 10 years or something. I know I've seen slides from the district where that's been done before. But anyway, I think that's an area that's worth looking at. And the other question I had on this slide gets back to operation. We talked about the effect of lowering the stages in 3A, and reducing the flows through S334 obviously is another factor in compliance risk. But moving north, I don't recall exactly what the changes in operation at S151. it's about halfway up your slide there on the right, that, how much of the flow that goes south to the C111 base, how much of that is released to the east and goes down along the eastern border of the 3A versus going down the L67 to S333. That split, obviously affects the amount of the flow volume to S333 and the compliance risk. So I think that's one part of, if you look at operation, that would be one thing to examine. It looks to me likely that most of the flow is going down the L67. But anyway, that would be something worth looking at.
Okay.
This is Donato. I wanted to follow up on one of the points that Stuart had made earlier. I am in complete agreement that what we're seeing most of the time now, particularly coming from the dry to wet season at the 333 structure, is a localized phenomenon. However, I am not at the point where I can rule out the external sources during the rest of the year, particularly John pointed out earlier in his presentation. I don't remember the slide number 8, where he talked about some spiking events that occurred in the auto samplers for the concentrations at S333 and the link between S9 upstream on L67A. So I'm not really at the point where I can eliminate those external sources yet, but I do think that when we're seeing these spiking events coming out of the dry season and going into the wet season, I think evidence is pointing to that in a localized dynamic, specifically when you look further upstream and you're not seeing the magnitude of these spiking events. I'm going to use Dan's over.
Yeah, the Corps is keeping us straight with that. I've used theirs at another meeting. Thank you, Donato. Let's see, Paul Julian looks like he would like to speak. Paul?
Hi, Julie. Thank you very much. And to get back to Stuart's point regarding the trend analysis in the SFER Chapter 3A, we do both a station-specific trend analysis as well as a regional trend analysis. The regional trend analysis, of course, is the different compartments of the protection area, and we parsed it out from inflows and interior locations or regions, if you want to call it that. But also on a station-specific trend analysis, we both do it for kind of looking at the TP rule, quote-unquote, compliance assessment in Appendix 3A6, and that's specific to marsh locations, specific to the 4-part test evaluation. We also, in Appendix 3A4, we have a trend analysis for each individual site. It's table 3 of that appendices. This is actually an annual trend analysis going all the way from the period of record of water year 1979 to, in this last SFER, it's 2019. And that's state water year, not federal water year. We could hypothetically explore the seasonal analysis if needed, and we can also adjust the time frame in which we do the annual analyses outside of the SFER if needed.
Okay, thank you, Paul. Anything else from the reps or technical staff right now?
Yeah, I just had another question. If you go to the last slide, go to Stuart's slide.
And this is Bill speaking?
Yes, I'm sorry.
Okay, just wanted to make sure I got it. Thank you.
Stuart's, yeah.
Oh, I'm sorry. I misunderstood what you meant by last slide.
Yeah, the Stuart's presentation.
That would be slide. Yes.
Yeah. Okay. I guess it's kind of linked to the trends, but I don't know. When I squinted at the data with different methods, I was sort of seeing, maybe it was my imagination, but a pattern moving along the western edge of 3A from the western basins, from the L28, which has very high concentrations, and possibly affecting the concentrations way down at S12A and B. And even looking at S334 along the way, and the trends also, because the concentrations at S12A and B, A especially, are in the mid-range, if not slightly above the average. So the operational or the trends, I think, is not just a matter of S333. You ought to be looking at the western side especially, and whether it's linked to the upstream sources, because I don't know what happened to the WERP program, but there has been plans to address those upstream sources in addition to STA 5.6. So
yeah, I can speak to that a bit. I mean, WERP is still in its planning phase. There's been a little break, but it's coming back. But I do understand I believe I understand your perspective on looking at the monitoring at the structures that we have in this area, S140, S190, which is upstream a little bit on this interceptor canal, and we know the effects that's localized effects that Stuart had mentioned in the marsh areas. And I think, there's limited resolution of phosphorus data throughout in this area, but we do have, this map does not show the TP monitoring sites, but the marsh interior sites are very low phosphorus. And we do, but yet, as you indicated, at some of these structures where we monitor, we see elevated levels. But we see those not during periods when there's a flow, and not during the wet periods. We see those when it's relatively dry. So my personal opinion, based on some facts, is that in these areas that are adjacent to the marsh and canals, kind of similar to the L67 situation and along the L29 West, at a point in time where water levels decrease, this is where everything ends up. And whether it is algae or flock or other just concentration of nutrients in the water column because of the low water levels, that's when I see it.
Right.
Not, specifically trying to counter, but I think that's something to consider as well. That, and on those event basis, I think that's why we see it. But still, the source, the ultimate source of the phosphorus is not clear.
Well, yeah, I agree it's not clear, but I guess another factor is, first of all, we have monthly data and it's spatially sparse. And the transport of phosphorus, especially, could be it's very event driven. So you get a storm, a sudden rise in stage, and the chances of actually collecting a sample under those periods is, sometimes low. So we do have limited phosphorus data. But another signal that exists, I know it's very plain on the eastern side, and I'm pretty sure on the west, is that of sulfate. Sulfate would be largely, dissolved, and it gets converted and disappears once it hits the marsh. But there's a pretty good signal of canal influences moving north to south on both the west and east sides, as well as things like chloride. So those tracers, I think, give us some additional information. But I agree, if you just look at phosphorus concentrations, you could easily reach a conclusion that all the phosphorus is from the canals coming in from the north, is disappearing in the marsh, when in fact it's just going by when you're not there to measure it.
And I'll add to that, when we look at the spatial, so the GIS, the satellite imagery of this area, particularly over by the 344 and the 3434. I'm sorry, 343A. When we look at the GIS of those areas, you can clearly see huge, what look like airboat trails, which can create substantial potential for flow transport and thus nutrient and mineral transport as well. And when I look at the map with the overlay of the stations that we're sampling, those stations aren't actually in those airboat trails. So we could just be completely missing it even if we were there right on time. Over.
Thank you, Donato. Do we have any other comments or questions at this point on this? Because I kind of feel like if we go to our 3-step process here, we might not get beyond step 1, but I want to offer that we might. Because this has been a very healthy discussion, and I know we're all interested in understanding exactly why we have exceedances when we have them, and it's kind of important for all of us to move forward as we restore the Everglades here. If I get back onto our mission for the meeting here, I would ask the representatives right now, do we feel we've sufficiently evaluated the relevant information for a better understanding of what might have caused the exceedance? And then I'm just going to add, or do we need to go through this list of comments and determine which pieces the various agencies will bring back to the next meeting? So that's kind of where I think we may be right now. Or do you guys have enough information now to make a determination about error or extraordinary natural phenomena? So maybe...
So are you suggesting we can skip the number 2 and then come back to number 1?
No, I don't. Well, if you don't, regardless, we got to go back to number 1 is what it's sounding like to me. But if you guys all feel like you have enough information to do number 2, that's great. I'm asking.
Julie, this is Frank with DEP, and I'd be reluctant to say that we have enough information, that I have personally enough information to evaluate the cause of this particular exceedance, specifically at the S333. There was a lot of valuable discussions here, and I think a lot of tasks are some takeaways that needs to be evaluated a little bit additional before I can go back to my principal and have that discussion with principal and my general counsel to determine the path forward. So I would be reluctant to move forward past step 1 or question 1. Over.
Okay, thank you. What about Dan?
Hey, Julie, this is Dan Crawford. I think today's discussion was very informative. I've spent a lot of time looking at the historical stage trends and the historical rainfall patterns, and don't readily see a signal of anything that would constitute a quote unquote natural phenomena that was extraordinary based on looking at the level. But I will defer to, so in a nutshell, I guess I'm comfortable concluding that this is not a error-based exceedance nor a extraordinarily natural phenomena akin to the 2017 event, but I'm fully supportive of continuing the dialogue and allowing other members of the TOC and their support staff to bring additional information to the table.
Okay, thank you. What about you, Lori?
Yeah, I feel comfortable with what I've seen and heard, and in the conversation, I feel comfortable that there's no error. And John, if you can go back to the graph that shows the phosphorus with the 3 water years stacked on top of each other. Yeah, that's good. That'll work right there. So I guess what I'm seeing is if everyone just looks at May and June in each year, there is a trend. So what I'm again thinking is that, we probably need to look a little more at a localized issue at S333. And because we don't really have the rainfall pattern, I know John used, I think it was 44.1 inches for the year. I'd like to see that pattern wherever you calculated the rainfall from. So I'm not really seeing that there is a natural extraordinary phenomena. So I'm not seeing an error. I'm not seeing a natural extraordinary phenomena. But again, like Dan, I'm still open to conversations. And I think it would be maybe worth investigating, kind of zooming in on the 333 and looking at it, whether it is it a, sediment? Is it algae? Is it something to do within the canal? I think we may be setting ourselves up for a little more of a technical look at the 333. So, yeah, so that's my 2 cents. I may have given you a nickel, but there you go.
That's okay. We like nickels just as well as pennies. Thank you very much. Donato, do you feel like we've evaluated the relevant information, or did we need to still do that? And I based that question that way because of all the comments you guys have had.
With respect to the exceedance, the reality is we have beat this horse to death as far as the data analysis. I do see some value in pulling in some of the other concepts. Like I have not investigated an algal growth balloon dynamic as a driver for these events, and that's not even in my future project. So with that given, I feel like a little more evaluation of this is warranted. But just like Dan and Lori just pointed out, I'm pretty convinced there's no error. I don't really see much evidence here that this would be extraordinary natural phenomenon either. And like Lori just pointed out, there is a pattern that's happening which is localized, which seems to be localized at the S333, and that's what most of my data analysis and my other colleagues who've been working with me have been pointing at. So for me, beyond just the potential adding of chlorophyll, then I think we need to, because at some point we will get to Appendix C asking that question, I think we should start gearing ourselves up to figure out if this is a local dynamic, what local remedies we can be putting into effect. Over.
Okay, we are not very good at yesing and knowing here, but it sounds to me as though, and I'm going to base this a lot on some of the comments and questions that you guys all have. It sounds as though maybe many of us don't feel there's data error or extraordinary natural phenomenon, but I'm not clear that we have sufficient information to better understand what might have actually caused this exceedance. Is that kind of where we are?
I think so. That was Donato.
Okay, Donato, thank you. So I guess my next question from a process standpoint is, do we want to make up a homework list of additional information that we would come back with at the next meeting and go through the 3 questions again? How did you guys want to handle this?
So remind me what number 2 question is, Julie.
So number 1 question is whether or not we've sufficiently evaluated the information for better understanding of what might have caused the exceedance. And I think we all feel like we have some understanding of where to look. Question 2 is whether or not we've determined there's substantial evidence that the exceedance is due to error or extraordinary natural phenomena. And then if the answer to that is no, we then proceed on to Appendix C. So that's kind of the process we go through. Do we have enough information? Yes or no? Is it error or extraordinary natural phenomenon? Yes or no? And then if the answer is no to that question, we need to move on to applying Appendix C and considering remedies. Over.
I'm sorry, with the additional information, I forgot what your original question was.
Well, I'm not clear if, as a whole, the TOC feels we have enough information for a better understanding of what might have caused the exceedance. So that's, the first part of this. Many of you have already answered the second question. And I think that's okay, too.
So I thought you were driving us down a road to figure out what task would be disseminated amongst the...
Well, and in my mind, if we didn't really have enough information today, then yes, I think that's what we ought to do.
So my problem right now is I don't remember all of the stuff that was put on the table. I remember algae.
I'm going to try to go through my list here. So it sounds as though right now we're saying we don't really want to go past question 1 officially, even though we've looked at question 2. And I would say between TOC meetings, I encourage folks to be thinking about the 3-question process here, so that maybe if we land at the next TOC meeting that we need to look at Appendix C, maybe we would have already done that separately and or spoken with our principals. But I can kind of run through my notes if you like, and maybe we would all agree on who is going to look at which things, or if we feel we need to spend time on it. Do you guys want to do that?
I think that'll help.
All right. Okay. So let's see. And I am taking this in no particular order because I kind of took notes all over the place here. Frank wanted to know if we looked at the ambient water quality, and he was specifically asking about S12D and S152. And so I think where we are is we need a yes/no. Are we going to look at it for the next meeting, and who's going to do it?
Okay, I have already compiled it, so I can bring that to the next meeting if we want to go that route.
Okay, that'd be great. Why don't we do that? That'd be good. Thank you, Donato. Frank, I have a note about consistency with mod waters. I think that has to do with the percentage of water through S333.
Yeah, Julie, this is Frankie. That comment was just to make a recognition that that's exactly what we're trying to see. More flows on the eastern side of the 333 versus the western side of 333. And I thought that was the vision of the incremental testing, modified water deliveries in the future of COP. So that was a recognition, and Dan recognized that. So I don't think that's a takeaway.
Okay, great. Thank you. Donato asked about the whole period of record for rainfall over Conservation Area 3. Do we need to look at that?
I mean, for me, if you're going to couch this as an extraordinary event because of it being the third, I'm not really comfortable with 11, 12 years of data being used to characterize it as that. It just seems like it would need to have a broader breadth of data incorporated to make that assessment.
We can very easily, Julie, this is John Madden, just rank water year 19 in a longer period record for the WCA 3A rainfall.
Okay, great. I got you down for that. All right.
Can I ask a quick question?
Sure.
Hey, John, what did you use to get your rainfall years? Are you using a particular gauge, an average?
My staff. I think it's the district standard because that we report out on, but I'm not sure exactly what that is. I think it's an area weighted of multiple gauges. Or I'm fairly certain it's an area weighted of multiple gauges. I don't know what exact gauges those are, so I can return that information along with what I bring up.
Okay, that'd be great. Thank you, John.
And I think that gets to one of the questions that I wrote down from you, Lori. So great, thank you. Dan asked about stages further north. Do we need to look at that or not?
I think his thing was the stage relationship to the phosphorus concentrations further north. I have not compiled the stages associated with those structures further north, but I don't think that's a rough thing to add if we think it's needed. Dan, can you chime in? Do you think that's...
This is Dan. This is Dan. I would like to see if we're going to make statements about 333 headwater stage being the lowest on record over the year. I think it needs to be appropriately caveated by also considering whether stages further north in L67A indicate the same trends to get at the characterization of whether or not it was an extraordinarily dry year. I don't think it's appropriate to only look at local stages at 333 to make that type of a determination.
This is Bill. In the COP analysis, the model that we ended up with had stages, the northern stages, as well as the southern stages, and one of the significant factors was the hydraulic gradient. So, but I guess what I'm saying is that the COP models may be useful here. I think, the statistics have already been done.
Yeah, and for COP, Bill, this is Dan again, for COP, we specifically made the decision not to use 333 headwater because it does indicate a local hydraulic drawdown associated with running that structure more frequently.
So Dan, are you saying this is information that you guys have somewhere at the Corps that you could bring back?
Sure, Julie.
Okay, that'd be great, thanks. I have now officially found my highlighter, so I can highlight my notes here at my home office. All right. The other comments I'm hearing have to do with chlorophyll A. I'm sorry, I can't tell you anything about chlorophyll A monitoring. Bill, you brought up TSS. If there's something else we need to look at with TSS.
Yeah, look at the chlorophyll, look at the TSS, and as I said, the other indicators of algal growth, especially at low stage. In the EAA canals, IFAS did a lot of research on that showed that when the canals are stagnant, they release phosphorus and trigger algal blooms. So even though the concentrations are a lot lower here, the same process may be happening. But again, there's a lot of research that's been done on that, and I don't recall exactly when the chlorophyll A data stopped, or may have stopped at some structures and not others, but that's something to look at in terms of recommendations for future monitoring.
And does anybody want to volunteer to look at that?
Well, I think there's a combination of, this is John Madden, I think there's a combination of things brought up. If the chlorophyll data is not in DB Hydro, then it's not being collected or analyzed at this point in time. So there's nothing to look for in the record for water year 19. DO, dissolved oxygen, was brought up as something, and I'm sure we have dissolved oxygen levels during those collections. And if that would be helpful, we could summarize that alongside the TSS.
Well, there might also be a signal in the organic nitrogen, because that, at least in other reservoirs, chlorophyll and organic nitrogen are pretty strongly correlated. Here it may be swamped by the other sources of organic material, but I think, yeah, when you look at the DB Hydro data, include organic nitrogen, maybe TKN.
That data might be limited. If you look at 3A, we have a whole section on nitrogen.
Thanks, Paul. So it looks like maybe we may or may not even have data to look at. I guess I would ask everybody to take a look at what you think's available for that particular problem. I'm not going to volunteer us to spend a huge effort on it because it sounds like maybe the data is not available. The other thing I heard was long-term trends, seasonal Kendall analysis. Bill, you asked about that. Is that something the TOC wants done and brought back? And if so, who would be doing that?
Well, again, I guess I suggest first, before you do a lot of work, just harvest what's already been done, because I've done some. It's on my website, and I know the district and maybe Paul has done some. So let's see, whether that's been updated through water year 2019. And again, before you start redoing it all, just make sure you understand what's already been done.
Can I follow up on that? This is John Barkett.
Hi, John. Sure you can. Thank you.
It just struck me looking at the data, which was quite impressively presented, albeit complicated. But if you look at this, I'm looking at the slide that has the 2008 to 2019 12-year period with long-term level effective, and it's looks like 4 out of the last 8 years, 3 out of the last 6 years, and 2 out of the last 3 years, there's been a phosphorus exceedance. And I don't think that's not the sort of trend line you like to see. 4 out of 8, 3 out of 6, 2 out of the last 3. And I've been playing with these numbers just mentally, excluding those with the highest rainfall, those with the lowest rain, trying to see any patterns. I don't know if that's a fool's errand or not, but it just strikes me as though you might want to look a bit more broadly and generally to see if there's anything from your existing knowledge, without having to do more work, that'll lead you to any conclusions. But again, 4 out of the last 8 years, 3 out of the last 6, 2 out of the last 3 is moving in the wrong direction. And even in one of these years there at 8.9, 8.9, 2010, it's the same number. I struggle looking at all the numbers to make sense out of anything, to come up with some brilliant idea. But it just seems to me, with all of the extraordinary knowledge that all of you possess, maybe if you sort of step back and take a broader look at this, you may see something that we're all missing.
Okay, thank you.
Julie, this is John Madden. I mean, I can offer, we have looked at that and tried to, I guess, characterize these water years with general statistics, and found that it is very difficult to look at the annualized values and really come up with a ranking. It's, I'm not trying to discourage anyone from trying, but a lot of either the timing of things during the year, or whether flows occurring in the beginning of the year with stages high, or entering the wet season with stages low, all those types of things you can find statistics for, but it seems like maybe the effort there would be to see why in these years, like those specific things in these years that occurred that did not occur in prior, or in the years that didn't. So it's mainly the timing during the year. And I think Lori alluded to some of that with the rainfall events as well.
I'll just give you one other reaction to that comment. It seems to me, as you're trying to zero in as best you can on potential causes for this particular water year anyway, then you should also correspondingly evaluate what solutions realistically are out there as you're identifying potential causes. So I would not separate those two items as you're doing all this other work to evaluate possible explanations, whether they're localized or broader than that. Also look at possible solutions, either on a localized basis or broader as part of the same exercise. I'm assuming you're going to do that anyway, so I probably don't even have to make the observation, but I'll make it for thoroughness.
Thank you, because I was also going to bring that up as we proceed on, maybe tidying up this particular agenda item. Okay, so here's what I'm hearing is many of us probably feel there is no data error and there's likely not extraordinary natural phenomenon, but we have identified a few things to look at. And we've assigned a few things to folks. That doesn't keep anybody from looking at additional information and bringing it back to the next meeting, so I wanted to throw that out there. So if you guys are okay with this, maybe we will move on to our next agenda item, but I want to come back at the next TOC meeting with the additional information that you all have agreed to look at and provide, as well as Mr. Barquette pointed out, we need to start thinking about Appendix C of the settlement agreement and what additional remedies could be taken if we figure out the cause of the exceedance. I'll put it that way, because it sounds like most of us don't really feel like there's a data error or extraordinary natural phenomenon, but maybe we'll leave that open for the moment as we look at rainfall patterns. Everybody all right with that?
Yeah, I think also, I guess it follows from Mr. Barquette's comment is, you know, he pointed out the pattern in the last several years was not ideal. But I mentioned the seasonal Kend analysis, but as I recall, looking at something like a 5-year moving window of the flow weighted mean concentration and the difference between the concentration and the limit, that there was a pretty clear signal there. So it's hard to look at individual years, but if you start to look at 3 or 5 year intervals, moving intervals, you can see patterns and trends. So, you know, one of the outcomes is from this process might be similar to what you've done in previous years, and that is, well, document the trends and say, well, you know, a lot of this is due to historical loading, and that's the effect of that is continually going down. It's maybe not going down as rapidly as it was before, but there's some hope that the problem will gradually, you know, fade away. But that doesn't discount the importance of looking at how the changes in operation recently will kind of set that back a little bit, unless they're modified to try to reduce the risk.
Okay, thanks, Bill. All right. I don't think we've got anything more we can do today on this particular agenda item. I am being asked about public comments. We're not like officially really voting on anything right now, so I don't know if we want to take public comments now or wait until we finish the next agenda item. For those of you that wish to make comments, it would be a little easier on us if you could wait. So please hold your comments. We'll do the Appendix A subteam update. We will get public comments, and we will do any other announcements and schedule our next meeting. I don't hear anybody shouting or jumping up and down on my computer screen. So why don't we do that? I really thank you guys for a great discussion, and we may hear more from the public comments also about this next item. So if we could move on to the Appendix A subteam update, I think we are ready for that. And I see a host of people listed there. I don't know, DEP, were you going to kick us off here on the Appendix A sub-team update?
Hey, Julie. Yes, this is Paul Julian with DEP. I can give a brief summary of our last couple meetings that we've had, and which will lead into the other discussions, if that's all right with good of the order.
Yes, and I think we have some slides, right?
Yes, I believe Donato and John have some slides that they want to show.
Okay.
While he's getting that put up, I can go through my stuff.
Okay, that'd be great. All right, go ahead and get us started, Paul.
All right. So the Appendix A sub-team met twice in April. It was two very productive meetings. We had a meeting the 8th and the 28th, and the team came together, and we had several things that we wanted to check off the list. One of which is revisiting our scoping document to make sure that it's still pertinent to what we need to be doing and kind of moving forward. There were no revisions to the scoping document, so it kind of stays as it is. Another item that came up as a topic or a to-do, I guess you can call it, is compiling a pros and cons list for each alternative method specific to Appendix A for Shark River Slough and Taylor Slough coastal basins. As everyone remembers, as John goes through the presentations, there's several alternative methods that are presented and discussed relative to the long-term limit and the flow weighted mean for the particular water year. So as the group did that, we went through each method and even introduced one, which this is going to be what John and Donato will be discussing. Went through each method and kind of gave a pros and cons of each one. On the TOC website as a read ahead, the pros and cons list was posted. I believe it's something along the lines of, the title is Appendix A, Pros and Cons Regarding Alternative Compliance Methods for Shark River Slough and Taylor Slough Coastal Basins. In that document, it's 3 sheets. It's a PDF. Sheet 1 and 2 are Shark River Slough specific. Sheet 3 is Taylor Slough and Coastal Basins specific. The header of the PDF kind of gives us introduction to what this is. Each method is outlined, method 1, 1.5, and 2 for Shark River, for instance. And also the relevant structures and kind of the quote unquote math associated with that is also there. And then of course we have the same thing for Taylor Slough coastal basins. On the left, there's pros, on the right, there's cons, or advantages, disadvantages, however you want to say it. And then, we just, as a team, the first meeting, we started filling out an Excel spreadsheet and matrix for these things. And then we left it to the team to provide comments, revisions, and edits. And then the second meeting of April, we finalized that through a team effort and did some wordsmithing for some of those so that it had the proper flow. And during those discussions, as I said, method 1.5 kind of came up as an alternative for Shark River Slough. And I guess that's what John and Donato are going to be presenting right now. That's it.
Okay, and I apologize. I don't think we were prepared to show that pros and cons matrix on the screen, so Kim may not.
That's fine. I just wanted to kind of verbally walk through it for folks in case they wanted to get oriented for it. So it's not a big deal.
Thank you. And any of you, including members of the public, can grab that particular document off the webpage. It is there. So, all right. Thank you, Paul.
All right,
Okay.
this is John Madden. Yeah, Julie, I think I could bring up that document after we're done with this presentation and share that on my screen. I'll make an effort on that, but let's
Okay.
get through this first.
I can read through it if worse comes to worse.
Okay. So we've been presenting method 1 and method 2. You've heard me mention that several times for Shark River Slough and show you the 2 values and I think basically over the last 2 years we've been presenting both those results. With that method 1 includes only the historic structures from 333 west and all the S12, and 333 is adjusted with that outflow through 334. And over the years, we added 355A and B, which rarely flow. But 356 is not considered at all. That's the pump station that's returning flow from the east, or pumping flow into the L29, the headwaters to Shark River Slough, the headwaters to northeast Shark River Slough, I should specify. And method 2 includes all those flows through the S356 structure, even though we know that some of that flow is including seepage return, meaning when Shark River Slough stages get high and in the park, there's a gradient to the east, which that groundwater through the fairly porous, transmissive geology, that's the word I was looking for, in that area, is conveyed back to the canal L31 North that to benefit the park, 356 is pumping that water back into the headwaters of Shark River Slough again to keep that hydration and limit the draining down of those stages. So we have been discussing part of the Appendix A subteam for some time to whether method 1 or method 2 would be more appropriate to move forward with, or if there was a different method. And I'm here to present, before any further deliberation by the TOC is made, we're going to put forth the method 1.5, we're calling it, and compare that to the other methods. I'm going to give a little background on the actual language in the consent decree to the settlement agreement. The Appendix A, page 85, describes our water year as October through September, of course. This is immediately following the equation that we use for computing the limit, and it describes what's used for the flow and also the flow rate mean. And the key language in here that we're focusing on is that we use the inflows to Shark River Slough for the water year, which is the S12s plus S333 plus any additional inflow from the WCAs established in the future. So again, this is a 1996 document, and at that point in time, 356 was not in place. And the concentrations were limits based on the inflow concentrations of the composite of all the inflows. So in considering that, we've been trying to, with either the monitoring we have or figure out what monitoring would need to be added in order to actually determine those flows at S356 coming from the WCAs. And so this concept is to approximate that, approximate the additional inflow term from the WCAs to Shark River Slough. And the way we apply this is the same as we do our other equations for moving water from 333 through the L29 to the 334. Kind of a difference between those is what goes to Shark River Slough on a daily time step. So we look at the daily minimum flow at S335 and S356 and combine that with the phosphorus at S356 station. So if we just focus on one side, I have two maps to kind of symbolize the different regimes of flow we have, but if we focus on the left map, S335 is in red here. This is a structure that basically blocks this canal parallel to Chrome Avenue, and it carries water primarily from the WCA 3A, 3B, really 3A, down around this eastern border and to this other intersection of canals down here is the L31 North and the L29. So the question is how much of this S356 water, this pumped water that's moving towards the west, is coming through 335 and considered WCA water, or could be other. So by using the daily minimum of these two, we essentially have two scenarios. So if S356 pumping volume is less than 335, so we have more water coming down through 335 than 356 volume, we assume that this flow is split, and 100% of this S356 flow on that day is from the WCAs. Alternatively, if 356 daily flow is greater than the 335, then it must be getting water from somewhere else. And so only the portion of water, only the volume of water passing 335 is considered from the WCAs. And that portion will be counted towards the Shark River Slough compliance. There would be other flow coming through 356 that would be assumed from seepage from this L31 North Canal. So looking at a few years of actual data that we've seen, we can kind of go back and assess, even though we haven't been reporting on it, we can see what those values would be. The 335 coming from the WCAs, the flow is the blue trace here. And where you see the red, that is the 356 pump station. Again, the 356 is starting all the way down here. These are not stacked on top of each other, so this is basically overlaid in front of the 356. So wherever that volume is less than both of them, it's indicated in green. So the green volume would be the method 1.5. The volumes in red would represent the method 1. And of course, none of these inflows from 356 would be counted in, oh, did I misspeak? It would be method 2, would be all the red flows, and none of these flows would be in method 1, but method 1.5 will always be somewhere in between those. It'll be the minimum of those two. And we can see, I also plotted on here the phosphorus levels. Seems like when we have those 356 is actually pumping, the phosphorus levels are low. Although when we see more stagnant water, they do go up. Okay. So on an annual basis, from water year 2016 through 2019, we have now the 3 methods comparison. We had been presenting method 1 and method 2, and in between now I have 1.5. And along the bottom, showed the annual volume that's being introduced to Shark River Slough through the 356 pump station. Quite a variation here. Water year 2016, we're at 50,000 acre feet, and only 4,000 acre feet, 29,000 acre feet, and this most recent year, 94,000 acre feet, the highest on record. So as you might assume, when we have very low volume through 356, there's very little difference between the method 1, 1.5, and 2. And when we're down at very low levels, there's also low phosphorus levels. There's very little difference as the concentrations are very similar. So it doesn't matter how much flow you have from the other side. If the concentrations are similar, you're going to end up with a similar result. As we get to water year 19, we saw a little more variation. There was a lot of flow, 94,000 acre feet, and I think we looked at the concentrations at 333 from the other presentation were 11 parts per billion, and on the they were lower on the 356 side. I don't have that exact number in front of me, but it caused difference of 10 and 9.3, which I presented, and then method 1.5 resulted in a 9.7 parts per million. So it's counting only the flow on up to the maximum of 335, or the minimum between 335 and 356. Long-term level, also the volume is a portion of what goes through 356. So it's always going to be, method 1.5 would always be between method 1 and method 2. So at this point, I'm going to hand control, or if Kim's able to hand control over to Donato, he should be able to use the slides, or if Donato, you want me to point, I can do that.
I would prefer to point.
I'm going to share it with him. Hold on. I'm going to send it to him. Okay. This is Kim. You should have it, Donato. You got it?
I see it. I'm just trying to get the pointer thing to work. Okay. Nope. Yes. Nope. Oh, it's a
looks like
lag. Oh, it's lagging. Oh God. All right. So thanks for setting it off, John. So John proposed this 1.5 approach, and this is something I actually looked at way back in 2015-16 period when we were trying to figure out how to approach assessing how we pull S356, how we parse it out from the 3B and the EMP return seepage. We didn't really have any monitoring in that area that would allow us to get clear specific numbers. So we came up with a series of different approaches that we could try to implement, which some of them relied on using those UVMs, the acoustic Doppler profile monitoring that was going on in the L31 North Canal, just south of the L29, to try to help us parse that out. However, those data are like a mile away, and then they step further and further as you get away. So you don't get a full signal of how much flow would be returning going north in the L31 North to go through the 356. So it didn't give you a clear picture of that. So this kind of gives us a decent way to assess how the 3B would be parsed out from the EMP. So I wanted to just see how that would evaluate out. And conceptually, in my mind, I said the 3B should most likely dominate what we see when it comes from, going through 356, as, because of the north to south gradient. So when I go back and I actually look at the concentrations in the flow volumes at the observed data, looking at what John just presented, where you're using the minimum, the 335 or the 356, what pulls out for me is in this period of time where the 356 is actually being used, you can see that we're ranging between almost 70% of the conservation area 3B being the dominant flows going through S356. So for me, that helped me understand. And this lower 21%, I'm gonna look at Dan Crawford to talk about the operations that were going on over there. So that one kind of concerned me, because this would be a year when we wouldn't have been really capturing what was going on in the 335 and going through the 356. But when I actually look at the flows, they were just really low flows. So, a small fraction of that low flow is what's actually showing up here. So again, my idea was here just to see how this actually functions, what the dynamic was. So it gave me some confidence, but it wasn't the full breath of confidence that I needed. And then talking with Dan Crawford and looking at what we'll be doing in the future, through what is known as the Combined Operations Plan that he provided a presentation to the TOC a couple of meetings ago. This alternative that fell out of that process is alternative Q, and he gave me the actual flows for the 356 and the 335, and I was able to do the same basic process that I did for the observed data. And it looks like we're going to be operating 335 a lot more in the future as we go into COP. And as a result, we get a higher fraction of flows that'll be captured here. So you can see here now I'm looking at around 53% all the way up to 100% in some years. And again, this is the modeled period of record, so that's why you're looking at 95 to 2006 so this is not the real world data. I didn't capture the whole period because then you can't really see what's going on down here in the differences in the actual flows. Again, this is 356 total, and then the blue represents the adjusted. But if I go back to 1990, there was only 1 year out of the whole period of the 41-year period of record that I saw that actually caused concern, and it was 1990. And in that period, that year, there was actually no flow going through 335 in the simulations, and it was just it looked like it was a dry year, and the operations weren't moving in that direction. So that was the only one that caused me concern. So when I look at these, how this approach is actually parsing out the flows, I feel pretty comfortable that we are doing a good job to represent it. But you have to understand we have not modeled this. We don't have actual flow structures in there to test this. And then one of my other short concerns was that little triangle down there. I mean, it's really blown up here in the picture that John has. It's a really small fraction of what's going on for the whole eastern side of 3B, and then what seepage we can actually observe coming out of there. But obviously, we won't be monitoring what's coming from this portion of 3B. But given how the fractionation is happening with respect to parsing out the flows, I don't find this to be a horrible approach, and I think it's a good approach to go forward. Now, the reality that I do have to point out is if we actually don't follow these flow patterns that we're observing in COP, I think we do need to come back and revisit it. So if we're completely saying that it's like 10 to 15% every year after year, because we're not moving the water through 335, I think we might need to come back and revisit it. But as it stands right now, I think this will lead us forward and simplify the compliance reporting. Unless there are questions, I'm going to pass it back to John.
This is Bill. I think there's another piece of information that I think is already out there in some form, and that is the RSM output in one form or another. They did, water flux analysis that would let you get a handle on how much of that flow that comes through S356 comes from either S335 or seepage into that canal from 3B above S356 and S335. So, and the recycle from the park along the L31. And I know that was done for at least one of the RSM runs, and I don't know whether that's updated, but my sense is that is kind of consistent with what Donato was showing. But it's a piece of information that could be dug out.
Okay, thank you. It might be easier. I guess my question for the Appendix A subteam folks is, did you want the TOC to vote on something here associated with Shark River Slough? And if yes, John, are you able to show the pros and cons matrix? I'm processing a little bit here because I thought the 356 was supposed to capture seepage, and it looks like it's sometimes capturing more seepage than sheet flow from the conservation area through 335, but not necessarily always. So.
Yeah, we can do one of two things. Kim, either you can share that document, or if you stop sharing, then I can share my screen.
Either way, I don't care.
Can you go ahead and bring it up?
Yeah, you want me to? I'll stop sharing and then you will.
Sure.
Or did you send it to me?
I've got it open. Go ahead and just stop sharing.
Hey,
All
Julie,
right.
this is Paul with DEP. Regarding the voting situation, I'm not sure, honestly, and I think it's above my pay grade to make that decision if there needs to be a vote. So it's up to the TSC members as well as their principals to determine if we need to vote.
Okay. And I don't know if we have enough from our principals yet on this particular topic, but I think some of us have a little feedback at least. All right. Well, let's show the pros and cons matrix, and then I'm still a little confused about the sheet flow from the conservation areas that we're supposed to be looking at. I just want to make sure we're all on the same page if we think that's being captured appropriately by these methods or not. So.
Okay, a little technical difficulty. My computer doesn't want to share its screen. So, Kim, if I believe, oh wait, maybe, no. Violetta sent you the document. If you can open it and then share your screen, that should work.
Okay, I'm working on it. Give me a moment.
Thanks, guys and gals.
I'm going to end the presentation. Is that okay?
Yeah.
So.
Okay. We can always bring it up. All right. To my email.
And while Kim is doing that, I do want to apologize to everybody. I have not been keeping track of the time, so. If somebody wants a lunch break, let me know. Otherwise, I think we want to finish up here. I don't think you guys want me to sing and dance while we're waiting, but
my apologies. I'm having trouble relocating the screen that lets me share.
It might be a little difficult for me. I've actually got the document up over here on my screen too, but I'm kind of junked up with a bunch of
Zoom might be under one of your internet icons.
Yeah, I come up with the Zoom thing, but it's not giving me share. It's not giving me the same. Yeah. My profuse apologies. This should have been seamless, and it's not working.
Does it say in the middle, share screen, or at the bottom, share screen?
Yeah, no, I'm just getting a message that says, it looks like I'm unable to connect, try again, but I believe I'm still connected. Let me try that. No, because it should have signed me in immediately. Did I end it by mistake?
Just sign out and then sign in again.
Okay.
Okay, so it looks like Paul may have brought up the matrix. Is that correct, everybody?
That is correct. The matrix is up on my PC.
Okay, and Paul has grabbed control, so I appreciate that, guys.
Oh, good. Thank you.
Yeah, sorry. We're all getting used to this virtual meeting idea. So let's just look at Shark River Slough only, because I realize many of the TOC reps were also on the Appendix A subteam, but I think we have an obligation for you guys to kind of make sure we all have a feeling for what you looked at and what you thought of the three methods for Shark River Slough. And the public obviously needs to know what you guys considered.
Yeah, Julie. So I can walk through this just a little bit real quick. So as you said, the TOC reps, the federal parties TOC reps were in the Appendix A sub-team. I believe you were on a listen mode only. And I'm not 100% certain if DEP's or Frank was on that call. I doubt it. But so full transparency kind of situation here. This first sheet here is Shark River Slough. The pros are on the left, the cons are on the right. And this is just for method 1 and method 1.5. And in that next to the method number, you can see that there's the structures involved there. Method 1 is the purest form. If you're not talking, go ahead and mute your microphone, please. So, like I said, method 1 is the purest form of the settlement agreement, Appendix A, Shark River Slough. And the essentially the pros of this are the accounts for total discharges to Shark River Slough through the S12s and 3 through 3 as originally envisioned. And it's the simplest monitoring scheme to account for those discharges in phosphorus. Of course, the disadvantages of that is there's no account for 356, and in COP, it's suspected that 356 will be used to maintain the operational phases of L29, and it doesn't really, and not accounting for those additional inflows from the water conservation areas. So as what method 1.5 and 2 do, that kind of goes against the original scope of Appendix A. I mean, if you want, I can walk through each one of these. I can keep going if you guys want me to.
Well, I think we can all read. I would like for you to touch the high points because we have the public listening here.
Okay. All right. That's fine. So for method 1.5, the one that John and Donato just presented, as they discussed, it parses that seepage from water conservation areas and sticks kind of closer to the original Appendix A language, as in a quote-unquote additional inflows from water conservation areas. And it leverages the existing infrastructure that's currently installed. It doesn't mean we have to install more monitoring locations, such as those flow monitoring locations that Donato referenced, or including more. And the existing water quality monitoring network is in place. The one disadvantage, or the disadvantages, I guess, holistically, is that this is a relatively new method. We haven't seen it kind of put through its paces to the most extreme. John provided and Donato provided kind of stepwise evaluation of it from 2016 to this current water year to kind of really do that. But again, there's some caveats that both John and Donato mentioned. And and Donato also brought up the seepage between 335 and 356. There's a potential there for uncounted seepage from Water Conservation Area 3. Another point that you could maybe suggest as a con for this is that as you incrementally increase the number of monitoring locations, you do have some uncertainty factored in there that could be multiplied.
Paul, I have a question on method 1.5. What concentrations are you using for the term in brackets? You know, that all the way from S333, S335, and S3.
That would have to be deferred. I'll defer that to Donato and John.
Yeah, historically. Go ahead.
Simple answer is the concentrations at 356, the actual measured concentrations into the L29.
But how do you do that min calculation? You know, the term in bracket. Historically, we use just S333 minus S334, and we use the S333 concentrations. So how are you doing that calculation now? Because you've got the additional inflows, S330, 355, and the additional outflow, S356. Now, I guess I'm a little concerned about the mass balance. I don't know, maybe it's too complicated a question, but so on each day, are you determining the net, the minimum of 0 or the maximum of 0 and the net flow of the terms in brackets? Or are you doing some kind of a load balance to account for the fact that the concentrations at S355 and 356 are different from S333?
Okay, the method 1.5 on the table here, and the data that was shown proposes to use concentrations only at the S356 pump station. So the daily minimum of flow at 356 and the upstream 335 is combined with the daily phosphorus concentration at 356.
Okay, so I guess maybe the easiest way to get this, maybe just have another equation that shows how you arrive at the final flow weighted concentration, because here you're just showing flow. So if you had another equation that just shows how do you calculate the combined flow weighted mean when you include all these sources. All right, it's too complicated. Let me, I'll send Donato an email, see if I can explain it better.
Hey, John, this is Stuart. Can you hear me?
Yes.
All right, so I think you have a spreadsheet that you have put together all the data to show how the calculation would actually work. And I just wanted to add a little bit more that it is you got two parts to this calculation. One is determining what flow would be included in determining the limit. So every single day of discharge that would meet that min test would be, coming from 335, would be included in the total inflow volume to compute the limit. However, on the flip side, because the monitoring for the concentration is done every 2 weeks, every single structure, the S12s, S333, S355A, B, S334, S356, they're all done on the same day because of established precedent. So it is possible that there could be a number of days in which there is water coming from 335 that passes through 356, but because of that biweekly sampling scheme that's been set up as precedent, that the sample could actually miss some event. Right. So there are some constraints in terms of how much of the data collected every 2 weeks would be on those particular flow days.
Right, okay.
And so just as for perspective, the reason why those structures are listed like that is, for instance, for the the tracking sheets that are provided to the TOC and the public, they have an alternate method here outlined, and this was just purely for reference, nothing else, to remember what structures are involved in determining the limit. I believe, as Stuart mentioned, John put together a spreadsheet that's very similar to those tracking sheets. It's posted to our Appendix A subteam FTP site, or a version of it is posted to that, so we can, if we need to share that, we can. But with that item being discussed, I think we can kind of move on, because otherwise we're going to gain a quagmire of technical discussion, which is fine. But in full guise, I kind of want to get through this pros and cons list. So continuing on for Shark River Slough, we have method 2, which is the method 2 that John presented earlier, taking into account fully the 356 discharges. Of course, the pros is it accounts for all discharges to Shark River, recycled or otherwise. And again, it leverages that existing infrastructure that's currently in place and installed, and has been running for a while. The disadvantage is that the 356 has a mix of seepage and additional flows from the water conservation areas, as well as return seepage from the park. So ultimately, you're going to be double counting because of that recycled seepage, so that's the high points, I guess you can call it, of it. Moving on to Taylor Slough Coastal Basins, this one's actually a lot shorter, oddly enough. So we have 3 methods that, if you have been tuning on to this channel in previous quarters, John's presented, and well, today, John has presented those methods prior. And again, it's an incremental increase of, as monitoring has come in place, and as the system has changed, those structures have been included. So method 1 for Taylor Slough Coastal Basins is just the 332D and S18C. It's a very simple method, fewer structures and fewer associated monitoring, and it's consistent with recent historical reporting. The major disadvantage is that it's completely obsolete, as it does not account for all the discharges to Taylor Slough and coastal basins, and it excludes those new flows, I guess you can call it, in the more recent history. Method 2 brings in G737 into the mix. It includes those surface water discharges from C111, but it does not include S328 and 332DX1 explicitly. And I apologize if y'all don't know where all these structures are ahead of time. And then, of course, method 3 is the incremental addition. As I said, it better approximates while leveraging the existing monitoring and infrastructure. So there's no more new infrastructure that needs to be built or monitoring needs to be installed. It provides a robust water balance for 332D, and closest method to use in using the spirit of Appendix A, as Donato liked the language in that, for direct inflows to the park. The disadvantage is that it ultimately increases the monitoring effort tremendously, from 2 to 6 monitoring locations. But then again, you kind of have a better approximation with that increased monitoring. And the disadvantage of having the increased monitoring is, of course, you can have potential for increased data gaps. For instance, the crew can't go out and sample, or a flow monitoring station gets shot at with a shotgun. That's happened before a couple times in South Bades, so it's not uncommon. With that, I can take any additional questions or redirect as needed, but that's kind of the pros and cons list for Appendix A, specific to Shark River Slough and Taylor Slough Coastal Basins.
Thank you all very much for going through that. I really appreciate it. I wanted to get this information out as part of our meeting today. We at the district have had a little conversation with our principal about both of these, and I'm just curious if any of you have feedback on either the Shark River Slough or the Taylor Slough Coastal Basins. I think one is a little simpler than the other one. We've already mentioned it's a challenge or it's complicated on Shark River Slough, but maybe Dan or Donato, have you been able to discuss any of these with your principal? Do you have feedback? Are you prepared to decide something? Not that we have to today, but we could on either Shark River Slough or Taylor Slough Coastal Basins.
Well, I think I might have had a misunderstanding. I thought we were bringing this here for us to actually come together with our own recommendations to take back to the principals so they can make the final decision. I might have misunderstood that process, but that's what I understood.
Well, yeah, me too, but we could realize as we've gotten here that we're not quite there yet. So I just want to poll everybody and see where we are.
I'm ready to pick methods for both of them.
And Julianne,
I'm rather to make recommendations.
Did you want to tell us, Donato, and then Lori can speak?
Oh, I said I was ready to make recommendations. I'm for Shark River Slough, I'm for method 1.5, and then for Taylor Slough and Coastal Basins, I'm for method 3.
All right, thanks. And Lori, you wanted to speak.
Yeah, I just wanted to say that I have had, I did brief my principal. I am ready to vote if we choose to vote, but if we're picking methods, you know, I would also pick 1.5 and method 3.
Okay. Donato, did you chat with your principal, by the way? I didn't hear that.
I have talked to my principal. I have told him I would be coming back with a recommendation.
Okay. All right. Great. Thanks. What about you, Dan?
Julie, this is Dan Crawford. I have confirmed with my principal, and similar to Lori and Donato, the core supports method 1.5 for Shark River Slough and the comprehensive method 3 for Taylor Slough Coastal Basins.
All right. Thanks. Okay, Frank, what about you? Where are you on all of this? And I realize maybe you're hearing some of this for the first time.
Yes, ma'am, you're absolutely right. This is the first time I've formally have seen this, and I just want to say to the sub-team, the Appendix A sub-team, you guys have done a great job in those 2 meetings to show so much progress in the last 2 meetings. I'm very impressed with all the work that you guys have put in, and I want to say thank you for that. Very productive. No, ma'am, I have not had an opportunity to speak with my principal regarding the methodologies with Taylor Slough or Shark River Slough. I can see the benefit, obviously, especially from a tracking perspective and a monitoring perspective and just a reporting perspective to have one methodology, and I can respect that. So my takeaway is that I will meet with my principal and my general counsel to have this discussion based on what I'm hearing today. So thank you, Julie. Over.
Okay, thanks, Frank. We have had some discussions, at least one that I'm aware of, with our principal at the district. I am personally a little more inclined to proceed with recommending method 3 on the Taylor Slough and Coastal Basins. I got to be honest, I have a little bit of a question still on even 1.5. Although of all the things you guys looked at, it seems to me that is as close as we can get at the moment to approximating inflows from the conservation areas, although it's not 100% clear. And then when I looked at Donato's additional information, I don't know, I keep getting worried about COP, you guys. And that's a little frustrating because it's very complicated. Do we feel that method 1.5 is as close as we're going to get, given the monitoring that we're doing?
I mean, unless you are willing to invest money into putting the monitoring that would passed the uncertainty test for people concerned about the level of rigor for that monitoring, I think we are where we're going to be. Bill did offer that we could look at the RSM to shore up what we're looking at right now, but beyond that, I don't know what else we would be pushing the.
Yeah, and I want to go back to a comment from Frank, actually, you know, and it's not just here in the past month, but over the years, I think all of you have put huge effort into looking at all this data and trying to come up with some responses. So I'm certainly willing to talk to my principal about using method 1.5 as well as method 3 for Taylor Slough and coastal basins. I know it's not exact, and that's certainly come across in the pros and cons, but it may be the best we can do at this time. And when you we've previously talked about additional monitoring, and we're talking about a huge investment there that maybe not pay off much in terms of helping us with compliance here at Shark River Slough. So this may be kind of the best is where we're at. So maybe, I don't know, I just polled all you guys. Does that mean we kind of voted, or do I need to get it a little more official here?
This is Lori. I voted.
Yeah, thank you.
This is Donato. I voted as well.
All right. So I think where we are is we've got votes from 4 of us, and Frank is kind of still looking at this. But it does seem to be we have a consensus, and I think from a process perspective, we need to get a confirmation from our principals that they're okay with this, and then we could move forward with these single methods of tracking compliance at both of these areas.
Are you looking for a motion or something? I motion to support what Julie just said.
Sure, that'd be great. And so let's say what that is. We're going to go back and talk to our principals about using method 1.5 for Shark River Slough and method 3 for Taylor Slough coastal basins, and bring a confirmation back at the next meeting. So does anybody want to second that?
This is Lori. I second.
Anybody opposed?
Hey, Julie, this is Frank with DEP. I just want to clarify that I'm still going to go back to my principal and discuss this methodologies with them with what I'm hearing today. So it's not a for or against type vote. I just want to put that out there. Over.
Yeah, I think what we just said is we are going to go back and discuss that we're ready to recommend these to our principals, but maybe we're not 100% here. So, and I think 4 of us are at least on board with doing that. So I think you're okay with your position.
Okay, thank you very much.
All right, thank you, folks. We're almost there, really. I really want to reiterate my appreciation and add on to Frank's about all the efforts on the Appendix A subteam. I'm hoping with concurrence of our principals that we've landed somewhere. Before we get to closing business and other announcements, I do want to take public comment. I don't want to leave that out. I apologize for the length of the meeting. For those of you who are members of the public who are attending, if you could please use the Zoom functionality to raise your hand, I will call on you, and our folks from IT will open up your microphone so you can speak. So I'm going to look at the attendees list for some raised hands for folks who wish to make public comment. And if we could, the first commenter, and please forgive me, I'm not going to get your name correct, Mr. Kare, or your first name is Yogesh, you can tell us how to pronounce your name when we get your mic opened up. And how do we tell if his microphone's open for him to talk, folks? All right, oh, good. I think you can talk now. So let us have your comments, sir or ma'am. Okay, not hearing any.
They need to press *6 on their phone, I believe, as well as getting unmuted by the IT folks.
Yeah, he's allowed to talk right now, so he just has, actually it says he's unmuted, so.
I know, that's what I'm saying too. So if you would unmute on your end on the phone itself, if you're muted, that would be helpful here. Okay, well, let's see here. I just want to see if we have something on the chat. I do not. Why don't we move on to Greg Munson and you.
I'm sorry.
There we go.
Okay, there was a confusion. Apparently, I'm logged in as Yogesh, but this is Melody from.
Oh, I see. All right, that's great. Why. Thanks, Melody.
I don't know. I'm logged in as Yogesh, but this is Melody from the Everglades Foundation. Sorry for that. Okay, so I would like to really. I have two comments about the meeting. So the first one is about Appendix A and the calculations. I first thank you, Paul, for presenting this, and thank you for the sub-team. We appreciate what you've been doing. And the table with the pros and the cons, comparing the different methodologies is very helpful. And we are very pleased that the parties are really very close to reach a consensus. Method 3 for Taylor Slough appeared very comprehensive, calculating all the flows to the Taylor Slough. That's great. Between method 1 and 2, method 1.5 seems a good consensus, so that's good. However, I think the public would need to have assurances that this method 1.5, is accurately accounting for all the seepage from 3B reaching Shark River Slough. So if we can start monitor this to differentiate between what's coming as seepage from Everglades National Park through L31N, and just to differentiate between the water sources to Shark River Slough, that would be great. Especially that we will have a blue shanty soon, so the seepage might increase from 3B. That's my first comment on this. The second comment, yes.
Go ahead, what's your next comment?
My next comment is about the water year 2019 exceedance. We have been observing these higher phosphorus levels with higher TSS at S333 structure for several years now, mainly during the transition period during dry to wet season. We saw it in 2014, 2017, 2018, 2019, and it's likely to happen again during this year. It would be great if the parties uses this TOC forum to give us more, to present us and discuss local remedies at S333 structure. We'd like to hear more about the type of sediments in the L67 canal, the transport of the sediments in this canal, how to operate S333 to minimize these events in the future and to reduce these events. Especially that also we would like to hear more about S333N structure and to see if how the S333N will be operated and if we'll see the same pattern at S333N. So this will be extremely useful for us as a public. Now regarding Stuart's comment about the external load to the Water Conservation Area 3, S334, yes, it's reaching the Q-belt, that's great to hear. We are looking forward to see the same pattern for the other STAs. And I think other than checking the the trend for water quality in water conservation area 3, a cattail mapping, a vegetation mapping for this area would be extremely useful. The last one that we had been like more than a decade now, and I don't know if the parties, if the different agencies are doing any cattail mapping, vegetation mapping for this area, and to see where we are from a vegetation standpoint. Thank you very much for this opportunity.
Thank you, Melody. Thanks a lot for your comments. We appreciate that. Thank you. Why don't we go to our next person who'd like to comment, who's logged in as Gregory Munson. So could we turn on Greg's microphone, please?
Yeah, he's allowed to talk now.
Thank you, Julianne. I appreciate it. Can you all hear me okay?
Yes, we sure can. Thanks, Greg.
Wonderful. Thanks for the chance to speak. Hey, we're going to hold off on final judgment or not, our final judgment until we look at it technically, but U.S. Sugar, who I represent, at the Gunster Law Firm, we're here representing U.S. Sugar. We are glad to hear that after years of effort, there's been considerable progress to update the Appendix A methodology. So that's wonderful to note. And you know, while we're a little concerned about the lack of resolution today as to dealing with the water year 2019 excursions, it sounds like the TOC is going to come back on that. So hopefully we can continue to make some progress there as well. Nonetheless, with the lack of resolution on what I would consider these two key issues, and with COP coming online in August, I think it makes maybe our original reason for commenting all that much more pressing. Specifically, we wanted to express some concerns about a letter from the Water Management District on March 16th to the Army Corps, responding to the Corps' combined operation plan and providing comments to the Corps about COP. And it suggested to us that maybe the district doesn't fully comprehend the consequences of an exceedance or an excursion, and where that could go under the consent decree. I think as this group is largely aware, the Corps' modeling under COP, and I think Bill Walker even referred to this today, it reflected an increased risk of violation under Appendix A. And the Corps in COP offered to implement an adaptive strategy to minimize that risk. And as I understand it, that would be to help keep the stage below that sort of magic line at about 9 feet, where the correlation with exceedances becomes much higher at that point. And inexplicably, the district's letter rejects that approach and says that the Corps should simply rely on, quote, already identified processes within the consent decree to address water quality, unquote. Any reader of that, we looked at that, it's very vague. I don't know what that means, already identified processes within the consent decree. It could be a reference to, hey, we're not gonna do anything in terms of remedies until SEP is built out. It could mean that we're going to excuse it for error or extraordinary natural phenomenon, or maybe one of the other mandated remedies in Appendix C. I mean, it's not clear, but frankly, none of those options are either clear enough for long-term reliance or involve some way of kind of relying on that outdated and fatally flawed methodology in Appendix A. And today's meeting shows just how difficult it can be to tease apart those various issues. So, anytime we're looking at a situation where you've got a water quality violation under Appendix A, there's this period of time because of the structure under Appendix C where it can easily turn into something with huge financial implications. And I mean that truly at the statewide level for Florida as a whole, for the Water Management District, and all the money that it has to be responsible for, and not just for U.S. Sugar, but for every single farmer in the EAA. I mean, that's what we're talking about when we talk about violations of Appendix A. It's a truly broad reach. And we were left scratching our head as to why the Water Management District would reject an approach that would implement some sort of adaptive strategy to minimize the risk of an Appendix A exceedance. So to wrap up, I would say I think we strongly urge the TOC to resolve the underlying issues, and whether ultimately where that ends up as a result of maybe some of the technical discussions today, I can't say. We think the best approach may ultimately need to be some sort of safe harbor under Appendix A. We're talking about excursions here that are below 10 parts per billion, the standard that governs just about everywhere else in the Everglades. But in the meantime, I think our main point is the district should not be telling the Corps to implement a protocol, an adaptive management protocol that could reduce the risk of an exceedance under Appendix A. Thank you.
Thank you, Greg. I think I understood all your comments, but you're basically saying if, based on the letter that was sent to the Corps, you're saying the district should consider the adaptive management options that the Corps is proposing. Is that correct?
That's it, Julie. That's it, summed up quite well.
All right, just want to make sure I had that straight for our discussions with our principals, which we will certainly need to have. So, all right, do we have any other members of the public that would like to give comments or discussion here at this point? I'm not seeing any other hands raised on my screen here, so I'm going to guess not. And I do want to thank Greg and Melody both for your significant comments. And
Julie,
yeah,
Bill, I have one additional comment that hopefully might alleviate some of the anxiety about exactly how these calculations are done at the south end. Now, anytime you measure flow, there's an error. Anytime you measure concentration, there's an error. There's a random error already, and there's also natural variation. That's really built into the compliance model. The standard error for the regression between concentration and flow in the Appendix A equation is about, I think it's 1.8 parts per billion. So if we get hung up on the additional uncertainty associated with 1.5 method or 2 method, I think if you do that comparison, that you're really not adding all that much uncertainty to the compliance. So there's a background uncertainty or variation that's built into the equation. And I think, knowing that, maybe you don't have to, I think you have to do the best job you can and make sure that it's accurate. That is, in the long term, it gives the right answer, but in terms of random variations, it's not likely to have a large effect on the actual compliance determination. Changes in operation could, but not exactly how you measure it.
okay. Thank you, Bill. All right. Let's see here. So we have some action items, and I'm sorry, I'm not going to go over those again. You guys all know what you volunteered to do. We'll try to get meeting notes out as quickly as we can as a reminder. For closing business, we do have some possible quarterly meeting dates. They're shown on the agenda. These were originally selected based on the availability of the auditorium, and I think we should go ahead and choose our preferred next meeting date based on what we have on here, and we'll figure out between now and then if we're going to be socially distant or not at that time. So do you guys have any preferences between July 28th or August 11th for the next meeting?
Julie, this is Dan Crawford. I'm okay with either of those dates.
Okay. Lori, Donato?
Lori's checking.
Thank you.
Yeah, August 11th would be better for me, but I can do the 28th as well.
Okay.
Julie, this
Frank?
is yes, ma'am. This is Frank with DEP. Either one of those dates will work fine for me.
Okay, Mr. Barquette, by any chance?
Yep, same's true. Either one is fine for me.
Okay, and Lori, what about you? Have you had a chance to check yet?
My internet is just so horribly slow today. The July 28th is fine, and that meeting got canceled, so August 11th works also.
All right, and since August 11th was better for Donato, both of the dates are fine for me, but why don't we go ahead and plan on August 11th? And I think it may be a little premature to look at October, November, so we'll stick with when's our next meeting going to be. So our next meeting will be August 11th, and I don't know if anybody has any additional announcements or anything we need to let folks know about. And I don't think I'm seeing anything with the hands raised. So I really, really appreciate everyone, the TOC reps, the technical staff, Mr. Barquette, our friends in IT, and all the members of the public, of which there's between 30 and 40 of you have been on the line. So I just want to say thank you so much for tuning into the meeting today, and I appreciate your patience as we are learning some new technology to do public meetings. And I am now going to close this meeting. So thank you all so much.
Thank you, Julianne.
Good job, by the way. Good job.
Thanks.
Yeah, I appreciate everyone who presented today and all the information that was provided. Thank you, Bill, for all your input as well. You guys did a great job. Later.
Yeah, thanks, Julie. That was a great meeting.
Okay, y'all. Thank you. We'll hear you in a quarter if we don't see you.